go. The blue bar is there to say we're live. Today is the 2nd of November 2018. On the panel is Astral. We've got another Richard, which is his logo is Let's Be PractiCOOL. And we have Dave Marsh and we have Mr. Thrive and Survive.
Hello, everyone.
Hello, everybody.
Hello.
Hello.
Hello, hello, hello.
Hello, good evening to everybody.
Yeah, it's very nice having everybody on today, and even more special in a sense because in less than 2 weeks, Mr. Thrive and Dave are going to meet up for the convention in America.
Yes, just over a week actually.
Yeah.
Well, like a week and 3 days, isn't it? Really?
Yeah, 11 days.
Yeah, it's literally like it's Saturday for me, Neil, isn't it? In a few hours, like it'll be Saturday, so I'll literally start getting ready, like, because it's obviously it's quite a big trip, so there's quite a lot of stuff to take.
Yeah.
Okay, just to tell everybody, if Dave just disappears for a second, he's uploading on his computer, and every now and again it cuts him out. Anyway, so what are we going to see, Rich?
Oh, I was just going to say to Dave, he's going to gain a lot of hours when he comes over here. He's really going to have jet lag, probably going back, because he'll lose them again.
Yeah.
Usually when you're coming back from America that you get hammered, seriously. Oh, hello, Patricia.
Hello, Patricia.
Hey, hello, Patricia.
Hello, Patricia.
Patricia.
No.
Maybe her microphone's not connected yet.
Patricia, can you hear us? She might, as I say, she wasn't feeling that well earlier on, so she might have just come on to listen.
Yeah.
I can hear some music in the background.
I hear it.
It's not me. It's not me. Anyway.
It's those pesky satellites, because sometimes, you know, I hear music and it's just, well, where does it come from? It's got to be them. Right?
It's got to be.
Anyway, Rich, you've come on today to talk a little bit about what you're going to discuss at the convention, aren't you?
Yeah, just a couple of things. I got a lot more to put together in the next 10 days. But wanted to cover...
By the way, someone's making a bit of noise.
Yeah, it's a
Dave,
hum.
Yeah, there's a hum going on between Richard and Dave.
It's not me because my microphone's off.
It was Richard. Poor Richard. He's got problems as well. Okay, sorry, Richard. You just have to unmute when you want to talk. Anyway, to the other Richard. Rich.
Yeah, so what we're going to do is Dave and I, we are going to combine forces. We're going to do a separate workshop. We're not talking in the main event. We have a separate deal we're doing. My understanding is they're setting up a whole bunch of workshops and people can just go to them if they want to or not. And we're going to do the moon. And I think with everything that we're going to cover a lot of stuff from a lot of different angles. And we're each going to have a different aspect and a different way of looking at the moon. To me, the moon is the smoking gun that destroys NASA's model when you really look at it. And I'll show just a couple things that I'm going to cover here, cover there beforehand. And then maybe afterward, I'll talk to Dave about it. Maybe we can combine forces and put together a video presentation of what we did there and upload it on both our channels. Because when you get the full picture, I think you will totally understand that what NASA has been giving us is total 100% bunk. They can't explain it. Even the gravity of the moon, I'm going to show that here in a second, can be debunked very easily as far as its association with tides. There is an association with the moon's location. But as you're going to see, there isn't an association with the gravitational pull like they tell us. And for example, I know Dave is going to be doing things that show probably, I think he's done it in his previous presentations, where he's going to be showing that Kepler's second law doesn't work because of the moon. The moon doesn't follow it. So there's all kind of things the moon destroys in the model. One thing I won't show here, but hopefully I'll be able to put an accurate representation of what I want to talk about. For example, a lot of people are asking me at different times, how can I start the explanation to talk to somebody about how NASA's model doesn't work and things like that? To me, the easiest one is to have people go out at after sunset or before sunrise, when your shadow almost disappears or does disappear. There's not enough light for that. But then look up in the sky when it's not cloudy. I know that might be difficult this time of year for the UK, right? But anyway, you look up in the sky after those times, and you'll notice that right after your shadow disappears, there's still enough light in the sky, especially this time of year. I don't know what it is about around the equinoxes, but the blue light in the sky can be seen from west to east. I don't care if it's sunrise or sunset. You can see it, the whole sky is still lit up blue, even though you can't see your shadow. There isn't enough light to see your shadow, but the whole sky is still blue from sunlight, supposedly. And if you do then the same thing, wait for a full moon, go out when it's overhead around midnight, you'll definitely see a very dark shadow that you cast, the trees cast, automobiles, everything casts a very definite shadow. So you have more light at that time in the sky than you have during those other periods that I just talked about after sunset or before sunrise. And yet you will see absolutely no blue around the moon. Now, if they're both outside their atmosphere, and the reason why they say the sky is blue is because the atmosphere, the way it is, takes the sunlight and diffracts it a certain way.
Light scattering, they call it.
Yes. So the same conditions have to exist. If you're holding a mirror of the sun up, they were supposedly launching this fake sun satellite or whatever that was supposed to shine back the sun to the moon. I mean, the sun's rays at different times of the day down on the earth. Yeah, that never happened, did it? But it's if the moon is a reflector, which it is, and if they went to the moon and we see it's a whitish gray substance, a little different than the Chinese, but every space agency that supposedly lands on the moon, the surface looks remarkably different. But it's still it's this powdery gray white, and you can get the exact lumen and reflective index from NASA, what they say it was, and this is why the astronauts were so brightly lit up, because it's just a perfect almost reflector of the sun back to the earth. And yet you can't explain why there's no part, not even a little sliver around the moon, that where you see blue in the sky. This is a proof that they're different lights, and there's just no way around that. There's no different coloring on the moon that would cause that blue to not show up by atmospheric scattering, which is what they say, if it is a perfect reflector of the sun, which it is. It's according to them. It's a just reflecting sunlight, bounces off, comes right to us. There's no reason why we should not have blue. So it's just little things like that you can start with, and just tell people, ask yourself, why don't you see any blue? You're seeing your shadow. There's more light in the sky, because at first they'll say, see, it's not as bright. That's why. Well, no, you can't see your shadow, so there's not that much light. And you see blue east to west, north to south. But yet you have a full moon overhead, dark, deep shadow, and yet you have absolutely no blue in the sky. Makes no sense in their model. So stuff like that I'm going to be doing on the physical side. And then I think combined with Dave's observations, it's going to be a perfect combination. And I'm hoping.
Just on the back of that, Rich, as you just mentioned there, interestingly, when you look at the full moon when there's a lunar eclipse, now the moon is supposed to be in the shadow of the earth. So if it's being completely blocked by sunlight, how the hell does that red shine through? Yeah, you know what I mean?
Absolutely. I've been talking about that since day one. How in the hell can you cast a red shadow? You can't do it. It's a physical impossibility.
It's impossible.
Of course. Yes, it's impossible. You can't do it. And I used to work with lights in a band. You can cast a red light if you have a red filter. And of course, NASA then, once everybody started asking about this, said, oh, it's millions of sunrises and sunsets that are cast from the Earth.
The light bending around the Earth, I've heard it all,
Yeah, and yet you can have what's called Earth shine, supposedly on the moon. You've seen it. You've taken pictures of it, Dave, with the crescent, but you can see the whole rest of the moon. You never get that red casting. So what, the sunrises and sunsets don't become red anymore, except for eclipse days? So it's just total bunk.
Yeah, it's a good one, that one.
Anyway, Karen, I've got the safety harness on.
I'll just put you on someone else, and we don't have to worry then. And then if you do, I'll just put it on. I've put it on the other Richard for a moment.
That was kind of nicely put. That I've got the safety harness on.
Yes, and I'm just going to go and turn my Wi-Fi off on my other phone. I think that's a problem as well. So I should be okay when I turn the Wi-Fi off, because obviously it'll give me a bit more bandwidth.
Yeah.
I've moved it, so you want to screen share, Rich? Go for it.
Awesome. Thank you, Karen.
We're on the other Richard.
Here we go.
Just
Okay, so what I'm going to do here, I'm just going to go to Paint.
okay. You're showing the Hangout anyway, Rich. That's it.
Okay. All right, here we go. Now, this is going to be part of my presentation, and I've got this one mostly done in the what's it called? The presentation software. Doesn't matter. But I'm having a problem with one of the slides with the picture, so I'm just going to open these up one at a time using Paint. What I did was, and I've gotten a lot of questions on this lately too, which is kind of surprising why all of a sudden this is coming up. I did a video in the fall of 2015, I believe, and it only has 11,000 views, but I totally debunk gravitational pull in the moon from NASA's bunk. But anyway, and it's only got like 11,000 views. I'm like, why did that video only have 11,000 views? I mean, I do a stupid Hangout talk while I'm walking my dog at the park, and I get more than that. But then I realized that was the first year I was doing Flat Earth, and I was only doing it for like 5 months. So I probably only had about 5,000 subscribers then. So anyway, let me show you this. What we're looking at here, I live right where this star is, or used to. This is Baltimore, Maryland, where the star is. I live out in Arizona out here now, but I used to go crabbing in the morning with my brother and friends and things like that in the Chesapeake Bay. And I would notice, even as a teenager, of course, I didn't give it a second thought, but when the moon was close overhead, we had low tide, it seemed like. And it always bothered me that was the case. It was like, no, I know science tells me that the moon when the moon's close, it's high tide. And I thought, well, maybe it's just because I'm in the Chesapeake Bay, all for the water to work up. But let me go ahead and show you here where the moon's position is, over just coming off the coast of Africa at a high tide in Baltimore, Maryland. Now I'm going to show 3 or 4 different places here, so you're going to see it's not just this. In fact, we're going to go to the Hawaiian Islands where there's no pushing up of water inside a bay or different things like that. And we're going to see that there's absolutely no correlation with tides and gravitational pull. So at high tide, the moon almost couldn't be farther from Baltimore, Maryland. Actually, if it was over here, I don't know if you can see, pretty much off the coast of India, that would be the opposite side of the Earth, because you see you have high tide when the moon is closest and when it's farthest away. Well, with Baltimore, Maryland, and you'll see if you go and look at tidal data of the whole East Coast, it varies within only about an hour. So we know the moon position doesn't move that much in an hour, and you can pick Florida all the way up to Maine on the East Coast, and this information will pretty much jive. But I'm going to repost this video because it's very important. Because this destroys NASA. So you have high tide when the moon is, I would say, it's not the opposite side of the Earth, but it's not closest either. So let me open up the next one. Here we go. Now, here's the moon in the Pacific, and Baltimore's having its second high tide. So again, what I want you to see here is the length of the boxes. And the reason why I did a box was just to show a nice, 90-degree angle, so you can see how far away is the moon when a high tide occurs. So see the length of this box. Let me go back to the one I just did, and you'll see that they're pretty close, but the second one is a little bit bigger. Anyway, you're going to see how this starts to starts to work here in a second here. This one. Now let's go to low tide. Here's low tide. Here's the center of the moon. Here's Baltimore, Maryland. Look how close its nearest approaches of the moon at low tide, the exact opposite of what NASA tells us. And again, if you pick different places along the East Coast and even the coast here, even Louisiana, where I'm going to be going to Lake Pontchartrain, I'm going to show that here in a minute too. You're going to see these things all correlate. So NASA says when the moon is closest, you're going to have a high tide. Well, that's false. So let me open the next one. And here we have low tide in Baltimore. And look where the moon is. This is the second low tide. So this is actually, like they said, it is the opposite of where it was, opposite side of the Earth. But this is when Baltimore and the East Coast should be having high tide. And if you check, most of them here will be within an hour or so of low tide. Makes no sense in their model. You make it a little bit larger so people can see it. That's it right there. All right, now stuff's going to really start making sense here, I think. Okay, now here's high tide in Hawaii. This is Kailua Kona, Hawaii. And you can see that high tide, the moon should be right under it, but it's not. It's a little bit off. Not too bad though. So we can give NASA this one. So why does high tide correlate here, but not on the East Coast of the United States? Let me go to the next one. I actually went out of order a little bit there. Hold on. Sorry about that. Showed that one. No, that's the wrong one. Hold on just a minute. I'm sorry. There we go. Cabo San Lucas. Here's low tide at Cabo San Lucas, California. Doesn't have to push up into a bay or anything. This is right at the bottom of Baja California. And here you have low tide. Look at the distance here. And remember, Baltimore was just a little teeny box. The moon was more over here at low tide. It was almost directly in the same longitude as Baltimore at low tide. And here you have low tide at Cabo San Lucas. Look how much wider the box is. So if you're going to say there's a gravitational attraction, I don't see any correlation. But by the time we get done with this, I think you'll see that there is a correlation between where it is located, but not a gravitational pull. There's some other force going on here. Okay, now this one right here, you got a split screen. Both of these are high tides in Cabo San Lucas. This is the one we just looked at over here on the right. And over here, you can see how much further away the moon is. Same thing. They're both high tides at Cabo San Lucas, California. So again, if you take this and compare it to the Baltimore, Maryland, or East Coast of the United States, makes no sense. But they are opposite sides of the Earth, so to speak, when they occur. There's just not, I don't know if anybody can see it, that there isn't a gravitational correlation. It's a position correlation.
This is the information they're giving us, isn't it?
Yeah, this is all their mainstream sites where I got all this data. For example, this Cabo San Lucas, and I went out 5 years. I went up to 2020. I did this in 2015, so I went up 5 years and checked this data, and it correlates almost exactly, but not totally exactly. For example, in 2020, you might find a high tide where the moon is like here, closer to where the sun is, or maybe it's farther over here. So it's not perfect, but it is close as far as position. It's just not close as far as a gravitational pull.
Yeah, Rich, you might be interested in all to see how many huge lakes are in that vicinity as well. You know what I mean? To prove that there's no movement at all on the actual lakes.
Oh, I'd love to be able to be that precise, but you know what they say, Dave? They say
it's millimeters. Yeah,
it's 3 millimeters. It's like, come on, are you really kidding me? You have more than that occurring in evaporation in an hour.
Exactly.
So yeah, there's no, and I've got two theories of what this is. I won't get into it now, but it's definitely not a gravitational correlation.
I think if you're probably thinking on the same lines as me in regards to like salt water being inductive and electromagnetism.
Absolutely, that's one of the theories. Yes, absolutely, and that also will correlate with ocean currents. While you have clockwise currents in the Atlantic, counterclockwise in the Pacific. All that makes sense when you look at it from an electromagnetic perspective.
And a lunar lemma perspective.
Absolutely. See, I think this is going to be very complimentary to our work here, Dave. So then we go to, all right, this is the one I showed before. This is the one I showed out of order. Let's see what else I got here. I'm missing something. Where is my... I've got the Louisiana one here somewhere.
You only know these things when you actually start looking at the information, don't you? That's why everybody needs to do their own research.
Yes, I just assumed. I really just assumed that it was always right, but it did bother me when I was crabbing. It was only when I looked at flat Earth that I start to say, hey, let me just see if there's a correlation like they said, because I always knew something wasn't right when I would go crabbing. Because crabbing, believe it or not, it matters what time the full moon is. Crabs, when it's a full moon, will what's called slough. That means they will shed their shell, and then you can catch soft shell crabs at that time. But they do it at certain lunar times, and we would look for that, and it just didn't make sense. It was like, wait a minute, why is it low tide? The moon's directly overhead, and or close to it. You know, we didn't have the internet back then, but you could just visually look and see it was, you know, high in the sky. But that's one aspect. I won't get into more, but I showed New Orleans that the box doesn't match with Baltimore, or it's actually close with Baltimore. I actually also did off the coast of Spain, Portugal, and the high tide actually and low tide does work with science there, but it doesn't work on the East Coast of the United States. So it just depends on where you go in the world. I looked up all kind of different places. The only correlation there is that, let's say you're in this part of Australia and the moon is usually in the middle of the Indian Ocean here when you have it. That's exactly where it'll be every time, give or take an hour. And the low tide will be on the opposites, or the other high tide will be on the opposite side of the earth. But if you're off the coast of Africa, it could be 95 degrees different, 150 degrees different. It just, as you said, Dave, it's more of an electromagnetic effect. I also think there's a possibility the moon could be moving through the waters above that are connected to the waters below. I'm not, you know, that's the theories I could flesh out, but
yeah, well, we know, like obviously, with magnets, obviously the magnetism obviously can be passed from one medium to the next. You know what I mean? We know that, so it
right.
is clearly a possibility.
Here's another thing I want to show here. I'm not sure if I can make this. I really haven't worked with presentation in so long. Is this big enough to even see? Oh, you know what?
Yeah, we can see it. We can see the track across America.
There we go. I just had to start the slideshow. Okay, here's the Great American Eclipse. This is the one we all know about. This is one I made several videos about, stating that the moon is only 70 miles wide. And I haven't even thought about putting that in my presentation, but I might. And I still get comments on that. No, the sun is further away, so it's a smaller light source. Yeah, all you have to do is go outside yourself. You have the same sun. Take a big beach ball, make that the Earth. Take a softball, make that the moon. Cast a shadow on the beach ball using the sunlight, and tell me if you can get the shadow smaller. And you cannot do it. You can't do it. And then they'll say, well, the shadow is actually, it includes the partial eclipse too.
Yeah, the penumbra. Yeah.
Yeah. Well, I say, okay, make a penumbra and an umbra, and make the penumbra smaller than the blocking object. You can't do it. You're not going to be able to make the umbra penumbra either. I mean, you can, but it's minuscule. You just can't. You can't duplicate what we see on the Earth. You can't make the shadow any smaller than 70 miles wide. Or I shouldn't say that. You can't make it any smaller than the width of the ball that's blocking. And using the eclipse and using the same sun and using a beach ball and a softball or two different size balls, do it. Go out there, use the same light source, and you will find, put little cameras or sensors on the ball and see where your partial eclipse, so to speak, is. We can partially see the sunlight and where you can't. And you're going to get an area no smaller than the blocking object every single time, which means the moon, if it's casting a 70-mile total eclipse, it can't be any wider than 70 miles. There's no way around it. They can say umbra penumbra all they want and partial and full. Just do it yourself. You'll see what I mean. You can prove it yourself. Anyway, one of the things I did in my video, which was actually a mistake, but it ended up being for good, was I showed at the beginning of the video these idiot NASA videos where the thing was, how does the path go west to east when we're turning to the east? And that was something that some flat earthers jumped on, and I knew not to do it because I knew their model would account for it somehow. So I left it alone, but what I left it at the beginning a little bit in my moon is 70 miles wide video, them showing one person spinning around in a circle and another person running around them faster to show how it can go west to east. I didn't comment on it at all. The only reason why I put that part of my video was I wanted to show how stupid, kindergartenish NASA treats us. And they had this goofy music going on with it, like a circus going on. And that's what it is. It's a circus. It's a dumbing down exercise is what NASA is. They dumb the people down. So, but like I said, I didn't comment on that part of it. I knew their model would account for it, but I got all kind of comments. The eclipse has to move west to east. It can't move any other way. Why are you, saying this? I didn't say anything. I just let them go on. So with that prelude, here was the path west to east. So then I looked up eclipse paths by NASA. And by the way, anybody who's listening, NASA does not use orbital paths and things like that to predict eclipses. Now, they may use orbital paths in their online projections to make it match an eclipse that's coming up. But all the data comes from a table that the ancients had. It's just a repeating pattern. Each one of these eclipses will repeat, I think, every 19 and a half years.
Yeah, every Saros cycle, they call it. Yeah, it's based on the Saros cycle. It's like 18 point something years, yeah.
Exactly. So they anyway, without getting too deep into that, and the ancients actually could predict on the lunar eclipses the exact shade of redness that would be in the moon. And these are from flat earth believers like the Mayans. So you don't need orbital, because I hear it all the time. You can't predict eclipses on a flat earth. Well, that's exactly what NASA's doing, because they're taking the data from flat earth believers like the Mayans and the ancient Greeks before they started getting into the philosophy of the globe. But that being aside, remember, they say it's always going west to east. Well, first let me point out, look at this path here. Yes, it's going west to east, but the moon has to be either slowing down or speeding up as this turns north, as it doesn't go directly east. Why? Because the Earth is spinning at the same rate all the time. And if it's not following a direct west-to-east path, it's going at a different speed when it turns north. That's just an aside. But I want you to look over here in Russia and down through, I think it's maybe northern India, whatever. But let's take a close look at this eclipse. Here's where the eclipse started, up here. The path moved east to west. Here's a compass. It moved east to west, then turned due south, and then towards the end of the eclipse, it turned west to east. So how can you explain that on the model if all these people were saying it's got to go west to east? Well, I got two people that challenged me on this, and they took me to a simulator where you can go back and simulate any eclipse in history. And they were trying to show me that the light was coming over the poles. Well,
Can
then
I ask you a question?
Yeah.
Mr. Thrive.
Uh-huh.
That there, it says it's gone from 1966 to 1968.
Well, that's all the eclipses. From 61 to 80.
Oh, all of them.
Yeah, but I did it close up here.
Also, that's on the equinox, isn't it, Rich?
Yes, and it ended up being an equinox date, which, believe me, I was shocked that it happened to be that date. And when he saw the date, he shut up. He stopped for a second. There was this long pause. The guy who was trying to convince me of NASA's model. And he said, I don't know how to explain this. He said, I was going to say the light was coming over the poles, but it can't on the equinox date.
Exactly.
So,
I'd be interested to see where the path of the moon is on that date as well, and all, Rich. Just to like verify it and all. Maybe I could look that up and add that to it.
Oh yeah, that'd be awesome. That was September 22nd, 1968.
Yeah.
Now, you do see a lot of these anomalies down way south and way north. And I'm not going to touch that because they're going to say it's light coming over the poles.
Yeah, they're big ones.
Yes. Yes. Look how wide these paths are. You should. Why are the paths different? Well,
Yeah,
maybe
plus
they have
something that I'm noticing there is that the total eclipses are more, well, okay, most of them are in the north, but the annular eclipses, if you notice, they're from like, the, well, southern half, if you understand what I'm saying.
Yeah, very good observation.
Just looking at it.
Yeah, I mean, you don't see anything really north of, I don't know, maybe the 40th parallel, except for maybe this one here. But yeah, this one here.
Yeah, that's the furthest one they've got, I reckon.
But anyway, that's another thing that destroys their model. If the mathematics and the rotation of the moon and the Earth are always in a way to where you have this west to east, and it has to be. Of course, they can't explain really if it doesn't go directly west east. They can't really explain a change in the speed. I don't think in the moon.
Yeah, interestingly, just on the back of that, Rich, because I was looking into the moon staying at 100% full during a lunar eclipse. Well, that exact phenomena happens on solar eclipse as well, and the moon stays at 0% for an extended amount of time as well. Usually, it's like a few minutes where it's actually at 0%. If you watch it on any simulation, moon calc or time and date, you'll see it's at 0% for like seconds or even minutes. Yeah, but on a solar eclipse, it can stay at 0% for nearly 12 hours.
Really?
Now, that in itself completely destroys the globe model, and same with the lunar eclipse staying at 100% for 12 hours as well, which time and date and moon calc both confirm that as well.
Yes, and they also what was the eclipse in lunar eclipse? When was it?
We just had the one in was it in July? Was it?
Okay,
And there's one coming up in January as well, January 21st this year.
Yeah, I think I'm maybe thinking about earlier, but maybe it was the July one. I'm thinking maybe January of last year, where the eclipse, that's where the shadow came from the top down as it was heading down towards the Earth. But that was the day that the moon rose before the sunset where I was looking at it. And it kind of dawned on me, it's like, wait a minute, it's not a full moon. How are we having an eclipse? Because they were both in the sky at the same time. And it wasn't even close. I mean, the moon had to be 10 degrees at least above the horizon, and the same with the sun. And yet the eclipse started a few hours after that. So it wasn't 100%. And I looked it up, and it wasn't even 100% until the next night. I'll have to go back and look and see, because I actually took pictures on my phone of that with them both in the sky, a video. I don't know if you looked at that, Dave, but that was one that happened here in North America.
No, I didn't see that. No, obviously, I was looking at the longest eclipse we've had in the last 100 years, which was the one what's just gone by in July, and obviously we've got this one what's coming up on the 21st of January this year, which is going to be quite a good one, where you should see it in North America and the UK. So it should be a pretty good night if it's weather depending, obviously.
Oh, good. Hopefully, I'll have a camera by then, and we can coordinate times and see if we can take footage at the exact same time. See if we get different results.
Yeah, like I say, because the amount of people who see a lunar eclipse across the plane, really, you know what I mean, that would be impossible on a globe anyway, you know what I mean, with the distance that they give us. So, but yeah, it'd be good to try and get quite a few people on board with this, and to make some observations and take some readings, and just then obviously get it all put together and see what we can come up with.
Yeah,
Hey,
absolutely.
you know what? We had a ladies' night last night, and we were talking about England, because in the Orkneys you get to see the midnight sun, but you don't in Aberdeen, but you do in Denmark. Isn't that crazy? But you don't in Aberdeen.
I can't picture because I'm not living there.
Yeah, it depends.
Aberdeen's right at the top of Scotland, right?
Yeah, it depends on your latitude.
That's why, even Roxanne and felt that the UK is lying on its side a bit, and that's why Scotland has longer light. And it just because Scotland in the summer is light for another hour after us. It's almost like they're in a different time zone.
Yeah, the further during the summer, the further the north you go, the longer the daylights are. Like I say, obviously, if you get to places like I don't know,
You know what? My friend,
Svalbard in Norway, you know what I mean? You're seeing like sunshine for like 4 months constantly. So
my friend
that's like,
is at the top of Denmark, right? But Denmark, where she is, if you looked at the map, it levels out to Newcastle. So if she's seeing the midnight sun,
Karen, that's wrong. That what you're saying. You have to look on a map again, please.
yeah, you look.
You're
You've got
way
a line
wrong there, Karen. It's not
up at
Newcastle.
the top of
Much
Denmark.
higher.
Well,
yeah,
it's about Newcastle. It's up there. It's not the end of Scotland. But
no,
if they're having,
Newcastle's
if they
only
have
like
a-
55, 50, 53, 54 degrees north, and I'm sure Denmark's a lot further north than
yeah,
that,
on the globe. The globe shows it like that.
just based on latitude.
Yeah. But-
Just while I remember, Karen, because I'll forget this. I was just what I was doing the other week. I was looking back on one of my old moon sinks I did with my mate Robert Jackson in Tasmania, Australia, where we both caught the moon at the same time. I caught the moon rising, and he caught the moon. Well, he still had the moon out for another hour there actually, so he had plenty of time to catch the moon. But when I presented it on Facebook and did like a post, you got a lot of globers coming on there saying that's possible on a globe, yeah, and they had this like picture of a globe, then they had the moon, and they had us both obviously looking at the moon from an equidistant position. Now, so I said fair enough then. So what I did, I just did a simple thing, and I went on to Mooncalc, and I went to 70 degrees north, and for 5 days straight, when the moon is on the Tropic of Capricorn, it's not visible. Now, if it's possible on a globe when one observer's in the UK, one's in Australia, and you can see the moon there when it's equidistant, why can't you see the moon, yeah, when it's equidistant and just incline 5 degrees from the ecliptic when you're at 70 degrees north? You know what I mean? It doesn't make no sense at all. You can't have it best of both ways, yeah? You can either see it from both locations or you can't see it from either on a globe. Do you know what I mean by that? It's probably best showing you on something like Google Earth, basically. So basically, if you stood at 70 degrees north and the moon is on the Tropic of Capricorn, you can't see it, even if it's on your meridian line.
Yeah, you've done a lot of showing us. You like using an app, don't you? And you see it all through that, don't you, Dave?
Yeah, I've been using like Mooncalc for like 3 years, so it's like my second hand, really. You know what I mean? If I'm showing you things.
All I think about you at the moment is going flip. Your little video you did for me.
Oh, you like that, did you?
Yeah,
it's cool,
flip.
isn't it? I was having a little bit of a debate with Chris Monk, you know, on that. Yeah, because you know he's got an answer for everything, don't you? Well, I proposed that to him about my moon sink, and he says, "Yeah, that's possible on a globe." Then I proposed, "Well, how come you can't see the moon from 70 degrees north?" Then, and he never answered back to that one because there's no answer to it. Yeah, you can't have both worlds. You can't not see the moon from two locations. Yeah, east to west. Then say, "Oh, it's different from north to south." Even with the tilt, the apparent tilt, you know what I mean? It would still be visible. Yeah, from 70 degrees north, even with that 5 degree inclination when it's on the Tropic of Capricorn. You can't have best of both worlds.
Absolutely.
You got it.
I got you there. Yeah, if you're going to see it 70 degrees east-west, you got to see it 70 degrees north-south.
Exactly.
On a ball.
And there is something else weird going on as well, because Dave's done some observations, and when he looks it up, it looks like a heartbeat. And then when that time, I've said it a few times on here, there was 2 equinoxes I watched, and then someone told me, go and look at the moon, it's going to go. And it did. It came in, it stopped, picked the stars up, went north and went off. And when you actually look at the wave it was making, it was like a heartbeat.
Yeah, well, what I've done now, Karen, I've gone a step further on that. I've actually measured the moon at its apparent furthest point at apogee. I've done it from actually 3 different locations, but I've only caught it once at perigee because of the time of the year. Yeah, the moon's not in the right phase for when it's at actual perigee, because it's always high on the Tropic of Cancer and it's always coming towards a new moon. But we're just getting past that stage now, and I managed to catch it 2 days before perigee. Yeah, and what I'm going to do, I've measured the moons using an app called Bearsoft image measuring tool, which is really, really, really good. It's really expensive. Yeah, I'm just using like a thingy version, like a free version of it, but it's really good for measuring. You know, like you can measure circumference, you can measure the radius, you can do what you want with it basically. So what I'm doing now, I'm measuring the actual size of the moon in pixels, and then I'm going to measure the actual moon rises, the meridian passing times, and the moon setting times over that time period. Yeah, and to see and then to work myself out a mean time, because people saying you can't measure the moon by just measuring the meridian passing. I say you can, but if you take the rise times as well over that period, and the meridian passing times and the set times, you will start to see a pattern. Like I say, even like I said with that heartbeat, you take that over a year and it produces like a heartbeat. And but where you're getting that peak, yeah, is not where it should be according to Kepler's law of planetary motion. You know what I mean? It should be a gradual up, a gradual down, gradual up, gradual down. But you're seeing a sharp increase and a drop, then a level off. Sharp increase, drop, and a level off. You know, like just like an ECG reading. That completely disproves Kepler's law. Because, like I say, you should see a gradual increase, gradual decrease, gradual increase over the year. You shouldn't see that heartbeat pattern. So that's like I say, I will be presenting that in a week's time as well.
Yeah, it's a bit weird, this heartbeat thing. Anyway, with all that Rich does, you're the perfect person to be around, aren't you, for him? And together. Yeah,
because like I say, I mean, I've got so many other observations and so many things I've done on the computer, which I'll share with Rich when I see him in just over a week's time. Because like I say, I've been doing so much more. You know what I mean? Just because I don't post it on Facebook, it doesn't mean I'm not doing something. I'm always doing something. Yeah, like interestingly, I've been measuring the moon on moonrise, and when it passes the meridian, you know, I'm measuring it then, and I had some interesting results then. I'm not going to talk about it on air, but I'll talk about it off air, because I don't want to give too much away, because I'm going to be working on something as well. So hopefully I can talk about that as well. And just one more.
P1000.
I haven't got a P1000. I've still got the Nikon Coolpix B700, which I still think is a better camera, personally. Like I say, it's 20 megapixel.
It's a beast.
Yeah, I know it is, but it's only 16 megapixel. I've got 20 megapixel, so I can actually snap an image at 20 megapixel and pull it closer to you, because I've got that resolution to do that, you see. So, you know what I mean? Even though I'm catching it, they're catching it at 3000 millimeter focal length. I'm catching it at 1440, but I've got more megapixel to bring the image closer.
Can I just ask, Dave? I'm just wondering, why would they make a camera that's only 60 megapixel and you've got one that's older and what do you say is 20?
Mine's 20.3 megapixel, yeah.
Right, okay. It just seems a bit going backwards.
Well, when Joe Hill was there for the same reason, or someone was talking about it on one of our hangouts, like, why only 16?
Exactly. When that camera come, I expected it to be at least 24 megapixel, at least, yeah, or if not 20 megapixel, same as the one I've got. Yeah, when they brought the same sensor out for it, because that sensor's too small for the camera, and you can't. You know, when you like want to control the aperture and the ISO, you can't do anything with it. So you always get these similar kind of shots of like stars and things like that. You know what I mean? You can never get that crisp image what you need for shooting that kind of night landscape kind of thing. So you're always going to be hindered with that small sensor, because it can't take a lot of light in as well.
So what would it mean though if you could go from a 16 to a 20? What would it do to the pictures?
Well, it improves the resolution firstly, doesn't it? You know what I mean? So when you do pull that image closer, it's not going to it'll make a lot of difference. You look at an old TV now, then you look at an Ultra HD TV, and you'll see a hell of a lot of difference in the picture. Because if you had a screen that size, what was only 720p, it'd look very pixely. You know what I mean? You imagine a 60-inch TV with only a 720p resolution, they look like Tetris blocks on screen.
I was going to say, if you get that camera and it had 24, you could probably zoom in on a cockpit of an aeroplane and see the sweat on a pilot. And I'm not joking, you probably could.
Yeah, they are. I mean, don't get me wrong. That zoom on that camera is phenomenal. You know the 3000 millimeter focal length camera, optical zoom. That's just like, you know what I mean? You'd probably pay about, I don't know, 10 grand for a telescope. What could do that like 10 years ago, 20 years ago? You know what I mean? So the camera is amazing, but like I say, I couldn't see any reason for me to update, really, because that camera does everything I need it to do. And I've caught all my images at 1440 millimeter as well, so I'm consistent with my images and all. If I got a P900, then yeah, the focal length 2000 millimeter, so I'd have to start all my observations again. You know what I mean? So if I can keep using the same camera, I can keep the consistency as well, because all my images are captured at optical 1440 millimeter, so I can get a consistent approach and obviously keep that consistency as I keep making my observations. Keep chopping and changing cameras, you know what I mean? You're not going to be able to compare it, especially when you're measuring the moon. You know what I mean? So because I can set my camera to 1440, which is like maximum optical zoom, and just keep all my images and all my captures at that, and then that's how I can use as a decent measuring tool. Then, can't you? If you're using different resolution camera and different megapixel and what have you, you know what I mean? You're not going to be able to have no consistency in your.
Well, Rich wants to buy a camera, so maybe it's not the P1000.
I mean, you can pick that camera of mine up now for like $300. Yeah, you know what I mean? $350 maybe. If you want to pay £1,000 for a camera, yeah, when that camera will do exactly the same, and it's got a better sensor in it, it takes in more light, and it does everything apart from the P1000 could do, apart from the focal length. That's the only difference.
What happens, Dave, to a camera like that if you get an external lens and put it on it to increase the zoom?
I've got an external lens on it, but I haven't got it for the actual zoom. I presume you could do, but I'm not 100% sure, mate. Because to tell you the truth, you can zoom right close in on the moon anyway. You know what I mean? You can get right up on Tycho's crater. You can fill the screen with it. That's not a problem. What you can do as well with that, because that's 20 megapixel, you can take an instant shot and then you can click on the image and then you can press a zoom button and zoom that image in more instantly. You know what I mean? So It's not a problem. You can work around it. Like I say, it hasn't got that zoom, but you know, the closer you get, the less stability you get anyway on the actual image you're shooting as well. Because obviously, when you get it closer, you know, it's harder to keep it in frame or keep it still in your frame. So for me, it's a perfect camera. And I paid £400 for it when it first came out. I would imagine now you could probably get them for 350 quid, $350, maybe $400, and it's perfect. And you don't look an idiot when you go around your neck when you're walking around with it, because it doesn't look out of place like the P1000 does. You know what I mean? You need like a wheelbarrow to carry that thing around. And that's the only reason why I didn't upgrade my camera. For that very reason. And like I say, I want to keep all my observations consistent, and I've been using the same. Even before that, I had the P610, which had exactly the same 1440 millimeter focal point, focal length. So even my previous observations can be matched up with my new this camera as well. So it keeps it all consistent right back through till 2016. So that's why I've done it.
I can't wait to see the new data you've got.
Yes, like I say, I'm constantly collecting data. In fact, what I'll do later on, I'll send you the images what I captured when the moon was at apparent apogee and perigee, and I'll show you what I've got up to now. And like I say, I've just got to work out that meridian passing over that time scale and the moon rises and the moon sets to see what the actual time difference is between them. Because as you know, when the moon's heading north, it does them big jumps. Remember when we had that light lunar standstill and the moon was doing them massive leaps north? Well, that's what it's just been doing recently, but not as big, big leap. But that's why the moon obviously rises a lot earlier every day during that time. You know, if you look at the moonrise times, they go from like 24 hours 50 minutes right down to like 24 hours like 10 minutes. You know what I mean? You're like, whoa, what's going on there? Especially obviously on that equinox, when the further north you go, it's actually at one point it's rising same time as the sun every 24 hours. Now that's nearly impossible. So
yeah, there's so many inconsistencies with the model, with NASA's model with the moon. It blows me away that people can't see that. It really does.
Yes, and like I said, the more time you spend on it, and I mean, like I say, I did get to a stage where I was actually thought I was not getting nowhere. You know what I mean? You just don't seem to get anywhere. But as more and more information comes in, and you gather more and more, you just start to see them little inconsistencies and them little problems with the model. Yeah. But like I say, it is like a frustrating, like a year frustrating, because you're observing the moon and you're just not seeing anything. And it's not until you start getting more and more data and you start pumping it into graphs, then you'll see the inconsistencies when you pump it into graphs, because you're not seeing what you're supposed to be seeing on their model. You know what I mean?
Yeah, exactly. It's when I was doing those measurements with the different weights at different locations. I'm going to bring that, by the way, to Colorado to have another data point. I didn't really see anything out of line at all. In fact, I was like, hey, there is something to this as you head north. It's things weigh more or less, whatever the way it is. And until I plugged it into the graph, I was like, whoa, this doesn't make sense.
Also, I don't know if Dave's got them now, but he was given 100 years of moon rises, and it came from NASA.
Yes, I got it from Steve Torrance, and it was all based on official NASA data on moon rises, which was interesting. Yeah.
Now, have you found that what they say matches up with reality?
No, like I said, the phases all match up with what they say, but like I say, I'm still the actual motions of the moon from my perspective as an observer. I'd have to say no. You know what I mean? What other way could we measure the speed of the moon other than using that meridian passing? You know what I mean? For that moon to occupy that spot, even on a globe, for it to spin a constant rate, and then that moon to occupy that spot the same night, if you can't use that time scale in between as a measuring tool, well, how could you ever measure the moon? You know what I mean? That's the only way we can measure the moon, and that's why I'm going to try and obviously do the moon rises, see what them times are, the times in between each day, do the meridian passing, see what the times are in between each meridian passing time, and do the moon set times to see what the times are, because then I'll get 3 lots of information instead of just using that meridian passing time. Then, you know what I mean? And when you put them into a graph, and you put them graphs next to each other, then you start seeing little patterns. So that's my next project, and hopefully I can get that sorted pretty soon. But what I wanted to just mention as well, you probably noticed I took my post down from Tattoo Fixers.
Oh.
I did get a nice little telephone call from the Lambert Studios asking me very nicely to take the post down, because apparently I'm still under contract until the last episode of season 6 finishes. So I had to remove the post. So
just explain to Rich, if he doesn't know, what you did, Dave.
Rich, I got approached by a TV scout to ask me if I want to go on the TV series Tattoo Fixers. What they normally do is somebody goes to Ibiza, gets drunk, and gets like a silly tattoo put on the back. What these guys do, they look at the tattoo and they cover it up with a nice tattoo. You know what I mean? But what I've gathered, season 6 is going to be about experiences. For example, one guy had a heart transplant, so his tattoo was going to be like based on his experience. A woman was in a horrific car crash, and her tattoo was going to be based on her experience. And mine, as a crazy flat earther, was going to be based on my experience. So it should be quite interesting, because they did take a lot of takes on the actual interview, and I started getting a bit suspicious after a little bit. I even questioned them and say, why do you have to do so many takes on the same thing? Just say it by doing this, you know what I mean? So, but I didn't enjoy the actual interview itself, but on the B-roll, going around the streets of London, shooting all scenes and all that was fun. And actually being in the tattoo studio and flat slapping everybody, that was even better. And actually bumped into 2 flat earthers while I was out and about in London, which was quite interesting as well. We bumped into 4 people, and 2 of them were flat earthers, so that was quite cool as well. Yeah, so it'll be broadcast next year, and obviously, like I say, I saw it as an opportunity.
You'll say Rich your tattoo, won't you?
Yeah, you'll see it in a week's time. So I got the opportunity as a flat earther to go on mainstream TV to promote flat earth. I had my flat earth t-shirts on. I was reading people's flat earth books, you know what I mean? My mate Mark's book I was reading. Mark Hollander, if you know him, he's got his book out, The Flat Truth. I was promoting his book. I was promoting Can of Art with my Can of Art flat earth t-shirt on, and I was flat slapping all day in the studio. Because interestingly, one of the tattooists, he's a flat earther too. So it was quite a good day.
So I just commented. So where did you have an image that they wanted you to take down?
I just put a post on about me and my experience at the the Tattoo Fixers. I just had a picture with all the artists and like the Tattoo Fixers shop. And yeah, and I got a phone call saying, everything okay? Is your tattoo okay? Oh, by the way, you couldn't take that post down on Facebook because you are breaching the contract. So I had a little read through the contract again. And like I say, I'm actually still under contract until the last episode is aired next year. So I took it down. You know what I mean? I didn't want to cause any problems or anything like that. But like I say, I saw it as an opportunity to, even if they ridicule it, yeah, put their own little twist on it, put some clown music in the background. Yeah, it's going to be a lot of people watch Channel 4 in the UK. Yeah, it's going to get millions of views. So it's going to open up. We're going to take Flat Earth from the YouTube channels onto the streets with all the activism, then into the homes. You know what I mean? So
can I just say, Dave, well done, because any kind of publicity is awesome, you know. And I take my hat off to you. I hope it's a good tattoo you got.
Yes, it's good, mate. Yeah, it's got the moon on there as well.
Quite a big one, though, isn't it?
Yeah, it goes from the bottom of my arm to my elbow. Like
plus, congratulations, because historically you must be a first.
Yes, it's like one. You know what I mean? I went on there as a flat earther, so yeah. They was all saying, "Oh, you're pretty famous in the flat earth." I said, "Yeah, I'm dead famous. I'm dead famous." You know what I mean? Blowing smoke up my own backside, kind of thing. But yeah, it was an experience, and like I say, I wasn't going to miss that opportunity to promote flat Earth, and I thought mainstream TV would be the perfect platform for me.
Did it hurt, the tattoo, being tattooed?
No, because I've had them before. You have to like pretend it's hurting. You have to like make like a wincing face, going, "Oh," but no, it didn't hurt.
So, what did you have to get fixed on it?
Dave? Oh, his computer's done
the
a
main
wobble
channel now as well.
now. You're back. We lost you for a moment, but Rich, say again, Rich?
What did you have to get changed on your tattoo?
I didn't have a change because what they're doing in season 6, the tattoos are based on the brand new tattoos based on people's experiences. Like I mentioned, that bloke had a heart transplant, yeah. So they're not cover-ups. The brand new tattoos based on your experiences, and mine's based on my flat Earth awakening.
Awesome. How long you been into flat Earth, Steve?
Since about November 2015. I think one of your videos is one of the first one I ever saw, actually.
Oh, that's cool.
Yeah. Going back when I can remember, like, yeah, because it was only there wasn't a lot of channels out right then. I think you had like Wakey, Dave, Eric DeBay, obviously Mark Sargent, and a few others, and obviously your channel. So there weren't a lot of videos to go through back then, like, you know what I mean?
Yeah.
I wouldn't like to try and go through them now anyway, because it's probably like, I know there's about minimum 100 million videos on there now. So yeah, there was only about probably 50, 60 videos going back then.
Yeah, and I find myself subscribing to 1 or 2 or 3 new people each week. Just they'll do a video I like, and just I keep the subscription going if they keep coming out with good content. So it's constantly growing.
Anyway, I send things to you as well, don't I, Rich?
What's that?
I bombard you sometimes with things, don't I?
No, that's a good thing.
In a sense, though, it's helped you with Dave, hasn't it? Because you really like what Dave's doing. So and doing the workshop with him. So it's really good that yeah.
Yeah, because like I say, if I thought back to like nearly 3 years ago now, that I'm just coming across them first videos on YouTube and like questioning it, you know what I mean, thinking, what the hell am I letting myself in for here, you know what I mean? Yeah, and like I say, who would have thought now we would be doing a presentation workshop together at the biggest flat Earth event in history. Yeah,
absolutely. You never know where life's going to take you.
No, like I say, you know what I mean. It opens other doors when you you know what I mean, when you're doing things like this. And like I say, what you can sit behind your computer, or you can get out there and do something. You know what I mean. And I've kept myself quite busy. You know what I mean. I've been done street activism in Liverpool, Southport. I've been to Speaker's Corner twice. Obviously, I've been on mainstream TV. I did the presentation at the UK convention. So you know what I mean. I'm trying to do my bit. I'm putting myself out there. I'm doing what I can, and like I say, I've got a full-time job as well. So it is quite a busy life, really.
I think it's amazing you randomly ran into other flat earthers.
Yeah, it was unbelievable. Like we were shooting a scene, and we'd asked if we can shoot a scene in like a cafe where we're reading books, and I was reading the Flat Truth book, and the guy come up to service, the waiter says, "Are you a flat earther?" He goes, "I'm a flat earther too." So that was the first one, and then we had to do some street activism. So I was on the corner of a street in Camden Town in London with my flat Earth banner, and first guy come up to me, he says, "Hey, yeah, I'm a flat earther too." He knows Dell quite well. He goes on beneath the imaginary curve? Is it
Yeah.
beyond the imaginary curve?
Hey, but I'm just going to add, don't you think that when the final cut comes, that those people that came up to you and said, "Hey, I'm a flat earther," that they won't be on it?
Yes, he will, because he's the only one I talked to in the actual B roll. Yeah, he's the only guy I had to talk to, and he had to sign the release form as well. So he will more than likely be in the video. The guy might not be in it in the cafe, because it was about me reading books and that. Yeah, there are some quite weird scenes I shoot, like, because even though I come across flat earth from YouTube videos, they couldn't really show that kind of thing, you know what I mean? They didn't really want to show any kind of YouTube, so I had to make out that I'd come across some information, like through some leaflets, some like flyers, and like you have to pretend to walk down the street and you got this flyer and you get like a ding, like a light bulb kind of above your head, you know what I mean? That's what I'm expecting anyway, so we'll have to wait and see.
So when does this air?
Rich, when you go out to that park with your dog, do you try and tell people about flat earth, or don't you do that? You don't tell them?
I'm a very introverted person, believe it or not. So it's just not my thing.
Do people recognize you where you live?
No, nobody's recognized me yet.
Oh.
Yeah, it'll be aired next summer or next spring, maybe, depending on where it is in the series. Like, but yeah, I'm sure it'll be advertised when it comes on, because it is very, very popular in the UK. And
yeah, I don't know how.
I'm going to say
ahead.
after the conference. Sorry, you go, Rich.
I was just going to say, I don't know how I would see it unless it ends up on YouTube or something, where somebody tapes it.
I think you'll see it. It'll come out and you'll see it. Believe me.
Yeah, I'm sure. Yeah, I'm
I was
sure.
just about to say.
You all in 2 weeks. Well, less than 2 weeks now.
Who said that?
Ditra in the chat room.
Yeah, see you in a week and a half.
I was going to say that Rich and Dave, when the conference comes, after this conference, I think your life is going to be totally different, because I'm expecting big things, you know, from what I've read into and what I've seen. You know, it's going to be well covered, well documented. It's going to be, yeah, your life ain't going to be the same after that. I'm sure it's going to change.
If you look at the information, what came out after the UK convention, there was a lot of publicity on that, really, but you didn't really see a lot of it. But there's hundreds of articles out there. It's on MSN. It's on all the like news media outlets on online. So there's loads of coverage of it. But obviously, because it's not mainstream, and a lot of these like news things now, you have to subscribe to them, don't you? You get the first half of the article, then you have to subscribe or whatever to the second part of it and stuff like that. So there is a lot of stuff out there, and I got approached. I got approached by BBC. Who else? Is it the Radio X? Is it another thing like that? Some other channels. So yeah, ITV for the interview when they went on TV. I actually got asked to go on that as well, but work wouldn't let me go on it and have the time off work. So. But yeah, there was a lot of publicity after that, really. So I would imagine in America it's going to be huge, because it's already building up now. And like I say, there's if you look at the news articles now, they're actually starting to build it up now. And I know there's quite a good one from one of the Denver local media outlets. So yeah,
they did a good job covering it. And Robbie Davidson, if he does like he did last year, he always gets a lot of media coverage there. Which is good. In fact, I was interviewed pretty extensively by a German TV. I never saw it. I don't even know who they are, but it was a German TV channel that interviewed me for, I'd say 35, 40 minutes. So yeah, you never know what's going to happen, but I hope, I did ask Robbie if he thought that the media would be in our workshops. And he said, there's no reason why they would not be. They can go wherever they want also. So I'm hoping they're there, because I think the moon, as I started out this chat with, it's the smoking gun. It's easy for people to see something's wrong with the model without getting into where's the edge and how do you make the sun and moon work, different things like that on the model, and how does the map work and all that stuff. It's simple stuff that they can look at and observe and see that something is definitely wrong. And hopefully that'll get them to start actually asking more questions.
Yeah, it's
Yeah.
good to stop with one subject, isn't it, really? Because you can't do it all, can you? You
Well,
can't.
that's what I've said. If you can just concentrate on one aspect of something, you'll get a lot further. Because, like I say, a lot of people will do a little bit of this, a little bit of that. You know what I mean? It's a lot of stuff to do. But like I say, I've just tried to concentrate on one aspect of it, and yeah, you do seem to make bigger strides by doing that. You know what I mean? Than doing little bits of everything. Where you get a lot of content channels where they've obviously doing a lot of everything. If you're just trying to concentrate on one thing, I think you will get a lot further. Because not only that, it gives you more scope for like to look into other people like who will concentrate on certain aspects of flat Earth. You know what I mean? Some people specialize in refraction, long distance photography, like Ranty. You know what I mean? A lot of his stuff's over like long distance photography over water. So like I say, I think it's good, like if you can get people to stick to one thing. I mean, some people don't want to stick to one thing, but me personally, I ain't got the time to like look into everything, so I can only do what I can do in the time I've got. Because like I say, I'm only ever getting like 4 or 5 hours sleep now as it is on a good day, so it's quite time consuming. And
I think we're called the night people now. 'Cause we're up.
Hey, can I just say there's a few people in the chat. I want to say hello to everyone in the chat. And also, Robin lifting the lid. They're doing a thing in London tomorrow. Do you want to say a bit about that, Karen? So we can get good support. It's John Smith. Yeah, go on.
I can't remember all the details, but it is tomorrow in London. They've taken over a school. And for a day, this school is going to be, hang on, let me just look up on the thing. Thanks, Astral, for doing that one. Now I've got to look up the details.
Well, we could ask anyone in the chat who knows the details, please write them in, and then we're all a little bit wiser. That'd be an easy way.
On Sun and Moon. There's a whole video with all the details on Sun and Moon. It's got Roxanne on it. I did it last night. Everything's on there.
Yeah.
Yes,
imagine that there was people that have just joined us today, Karen. That's my thought. Anyone new coming today and they're thinking, what's going on tomorrow, I wonder? Anything happening in London by any chance?
Yeah. Well, I'll try and put the link in of Roxanne's one.
Robin's wrote it in the chat, so thank you, Robin. That's great. Lifting the lid, yes.
So you've got the Globe End Tour on the 3rd of November at London. I've just seen it up there. I'll just read it out for you what it says here. It says, "Hi everyone. Last year around this time onwards, a small group of us got together as an unstoppable force in street activism. It was just awesome, starting at Leicester Square for the first time in my life. And now it ends in London." He doesn't say where it ends though. No, it just says
Robin in the chat has put the address and stuff and the times, and yeah, so we know.
Well, that's good because I ain't got the time on here anyway.
Have any of you converted any of your family?
Well, yes, obviously, in my previous relationship, I converted my ex. I converted a dad as well, and a dad's son as well. So I didn't do too bad there. Yeah,
That's good.
Yeah, in fact, Karen saw Susie's dad because we come down to that meetup together, didn't we?
Yeah, I did. Yeah, I've met Dave Marsh. Na, 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 na. That's what it'll be soon, Dave.
So you're north, is that right, Dave?
Yeah, yes. I'm smack bang in the centre of England. In fact, my village where I'm at now, Morton, it's actually got on the side the centre of England. So yeah, it's smack bang in the middle.
You must have a good observation point.
Not brilliant here. It's not too bad. I can if I walk up the road for about 20 minutes, I can see a moonrise. Yeah, and if I go in the field here and look behind me, I can see the sun and moon set as well. So it's not too bad, but it's even though I'm in like a village, there's still a lot of light pollution all around me, because you've got all the like Chesterfield and all the like places like Derby. Even though they're quite far away, you still get quite a lot of light pollution from them places, if you know what I mean. So
Yeah.
you don't get a very good night sky, really. It weren't too bad last night. It was quite clear like last night. So,
You know, I regret not knowing any of this earlier when I was in the Navy. Of course, you're in the middle of the Indian Ocean or wherever. It's just total no light at all, except for, whatever the ship's putting off. But even they don't like to put bright lights on and stuff like that at night. So I just really regret not paying attention to a lot of stuff back then, like seeing ships on radar 60 miles away and all kind of different things.
yeah, like I say, you'd probably spend half your time debunking the globe when you was on the ship instead of
I think I would have
country.
Yeah, I would have gotten early discharge probably. I should have thought of that. That would have worked.
That seems a bit strange, though, isn't it? It was a bit like when obviously I was doing the bit about the eclipses and noticing, from Robert Kidner that in Mexico, he's in the northern hemisphere, yet he saw his his eclipse was coming in differently. It's only when you start doing a bit of research or looking at it, you can see none of it adds up. And yet everybody would just take it all for granted. Oh, that's the truth. Like you've gone through what you were showing us with the tides. You only, because you know now that it doesn't work, even with what they're showing us. But you only know because you went and researched it or looked at it yourself.
Yeah, and it's amazing to me that people will not, the amount of people in today's society, it is really a testament to the education system who will just blindly dismiss almost anything that doesn't fit their belief system, ad hoc, right, instantly. It's just amazing how we've been trained like monkeys to just accept, open up the brain, put, pour whatever it is in the funnel and just accept it without question. And then if anybody questions it or asks you to question it, you're the idiot, you're the dummy, you're the dumb person for thinking outside the box. It really is a strange upside down society we live in a supposed enlightened society.
What would have happened, Rich, if you were where you are now, but you were still in the Navy? Then what would have happened? Because you'd have been questioning everything and they wouldn't have liked it.
You'd be saying, when we're going to Antarctica?
Yeah, for real. I
Yeah.
tried to get stationed in Antarctica. I really did. And when they couldn't guarantee it, that's when I left the Navy. I was due to be re-enlisted if I wanted to. And Weather Office and the Navy Construction Battalion, they were the only two people allowed in the enlisted force anyway into Antarctica. And you did 6 months in Antarctica and it counted as a year. Everything was double. Your time and rate, which means before you get advanced to the next level, accelerated double. Everything was double if you went to Antarctica. And then after that 6 months, you had your choice of duty station anywhere in the world where the Navy was. And I was going to pick Pearl Harbor, Hawaii. But and I was also recommended for warrant officer by my division officer. And it all sounded fantastic. But when they could not guarantee Antarctica, I declined it. And the only reason why I did that was because they lied to me when I went into the Navy and said, oh, you can go here and do this, do weather. And they lied to me and put me in electronics at first. And that's when I had to do all kind of things through Congress to get out of that and switch into weather. But if they hadn't lied to me when I was recruited, I would have probably accepted it and take the dice that I was going to get all that. But because of that, I got out. But I could have seen firsthand, couldn't I?
Yes, like I say, it would have been quite handy information to have here, because there's a lot of secrecy down there, and a lot of protecting of ice. You know what I mean? Yeah, they're doing a brilliant job to protect that ice down there.
Absolutely. I'm still thinking there's a lot of things to learn at the North Pole too.
Well, yeah, there is, because like I say, I mean, if you look at all the old Mercator maps, they're showing landmass there for starters, and that Mercator map now, we still use the UMT version of his map now, you know what I mean? So you can say he was a pretty good cartographer, so he was pretty good at map making, you know what I mean? So I'm sure he didn't make a mistake when he drew some landmass at the North Pole, some kind of landmass anyway. But if you look on a globe now, all you get on there is, you don't even get ice on there no more. You get water on the top of a globe now at the North Pole, which is interesting. You know what I mean? So you got ice on the bottom of the globe, but no ice on top. Like,
Well, you don't. Sorry, Dave. You don't even get that. You get the spindle on top now. You know. And
well,
I've
no,
seen exactly, but
that,
I've seen old maps like you have from 1500s and what have you. There's 4 landmasses at the top there, at least 4. Where did they disappear to? And why did we never hear about it on, Discovery or something? Oh, 4 landmasses disappeared. I mean, they were massive. You've got countries that are, a third the size of those or a quarter the size of them, haven't you?
yeah, there was
sorry.
about the size of Iceland each landmass. So yeah, it would have been quite big. Like, I mean, you can't confirm the maps. You know what I mean? They said that all the maps are wrong, but at the end of the day, yeah, they're still using a version of the Mercator protection with a universal transverse Mercator, is it? Yeah, that's it.
Yeah.
So
thing is,
like
though, Dave, sorry, when we've seen maps, not just one map, there's been various different map makers and they've all got, islands up in the Arctic Circle, up there.
yeah, so it's like it's interesting to see the evolution of the globe, kind of speak, because I think it's to try and promote the global warming personally. Why they don't have the ice on top of the globes no more, because obviously it looks quite good when you get a globe. So where's that ice gone? Didn't know all the polar caps have melted. So it's good for global warming, I suppose, or climate change, as you like to call it these days.
Well, I can verify we use Mercator, modified Mercator projections everywhere we sailed to. And even if you had Atlantic to Africa, I can remember plotting that as we went across. It was straight lines, 90-degree crossing latitude, longitudes. And we wanted to get somewhere straight or fast. We went in a straight line with it, not in a circle route. So I can attest to that because we plotted constantly. You had to in the weather office.
Yes, like I say, that's why that map was invented for that reason, weren't it? For straight line sailing.
Absolutely.
Yeah, and you didn't have to go up and down for different, like, what do you call it? The seas at different levels. You didn't have to go up and down for all these things. It'd be like going through the Panama Canal the whole, locks all the time if you had to go anywhere, wouldn't it? With the way that they've said, with the great big, what is it? There's a great big ocean wall out there in the sea, isn't there? Around the equator, there's all these things. There's different sea levels, and your boat ride would have been horrible.
Yeah.
I was going to say, here's a question. People that are sailing in the southern seas, they seem to have, they lose their bearings. Let's put it like that. Nothing seems to add in. We know this from previous accounts of, like Captain Cook and what have you, where they were forever running aground or things were happening. They were finding land that shouldn't have been there. And, they were like, it just didn't add up because of the maps that they were given. And according to where they should have been, according to their star charts and what have you, it just didn't seem to make sense. So something is definitely going on with the southern half of where we're supposed to be living anyway, that's for sure.
What I would say as well, there is a lost book from the 1400s called Inventio Fortunata. I don't know if you've heard about it. It's called The Unfortunate Inventors kind of thing, but I think it's from the early 1400s. And in that book, it's got 3 accounts or 3 separate expeditions to the North Pole, which was ordered by the King of England at the time, or whoever it was. I can't remember exactly where. And on 3 accounts, they all witness getting to a certain point at the North Pole where they couldn't get any further. They're saying there was some kind of barrier there. Whether this is true or not, or whatever, I can't confirm it. But the book confirms from 3 separate trips to the North Pole that they hit some kind of barrier. And if you remember ages back, Karen, when I mentioned it on Sun and Moon, and Darwin called me a liar on air, and I had to dig it out because I'd seen it on flat earth, flat water, and he actually read a section of that book out, and I actually had to dig around for about half an hour during the hangout just to prove that what I was saying I wasn't making up, and I had actually read it in the book and actually heard flat water play it on one of his YouTube channels. So that's quite interesting, you know what I mean? Because the way they described it, it's a very similar description of how the ancients used to describe how ether would be. You know what I mean? Some kind of matter which can You know what I mean? I can't really explain it. I call it like the fifth element. You know what I mean? It's like a mixture of all gas, air, water, all mixed together. Like, and that's the way I try and visualize it anyway. But if you have a little digging around in that book, there's a PDF version, and just look at some of them accounts. One was from like a sailor writing a letter to his brother, and one was like a bit like this smoky god, you know, based on the inner earth. One was like a father and son, based on a fishing trip. What went too far, where they went too far north, like, and there was like another account. But yeah, it's like I say, it's really interesting because they don't really mention the North Pole much these days, do they? It's always Antarctica this, Antarctica that. And even Admiral Byrd says, yeah, it's getting a little bit busy up there in the north these days. You know what I mean? But there's a lot more to do in the south. But like I say, I think there's probably just as much mystery in the north as there is in the south.
Yeah, I agree with you 100%.
Yeah, without a doubt. Yeah, and it's true that actually what you just said there, Dave, that we don't mention or we don't hear about the north anymore, do we?
No,
Nothing.
no, it's all Antarctica.
Yeah. Another strange thing as well, the South Atlantic, they've got a huge area of the South Atlantic that they've cordoned off, apparently. This is a nature reserve now in the middle of the ocean, and you can't go there. You can't take ships there or sail there, or it's like a no-go zone. So then I start thinking, well, why would they want to have something right down in the, I mean, it's to the east of the Falklands, kind of, you know, stretching over to, well, it's a massive area. It's almost as big as America in the ocean. What's all that about? I'm just thinking, like, you know,
Are Argentina launching rockets? Are Argentina going to start a rocket program? They'll need somewhere to crash the rockets, won't they? So
that's right.
Or somebody in South America, maybe Brazil, I don't know. But then they'll need somewhere to put the rockets down.
You know, Dave, I'm starting to think the ultimate compliment you can get in this business, if you want to call it that, is being called a liar, because that means they've run out of every other logical way to get around it. On my latest video, you know, I just talk plainly about it because there's so many videos out there that show ships and boats apparently going over the horizon, and then people take their camera, zoom, and they come right back. And I couldn't believe it. I mean, there must be 50 people. You're a liar. There's no such thing as boats going over the horizon or disappearing and coming back once you zoom in. It's like, don't these people ever investigate anything?
Interestingly, when I was on holiday and I was sat on the beach, with my feet up, I was reading through Ptolemy's Almagest, and there is a very, very, very small section in that book which actually mentions boats going over the horizon, which I thought at the time seemed a little bit out of place, because I know that they said that the Greeks believe that they live on a stationary globe and all that, but when I was reading that section of the book, it just didn't make sense, and it just stuck out like a sore thumb. I'm just trying to find the actual page now, just to give you a little bit of a read. I think I've got it.
Can I say something?
Sure.
About the P900? Like, see, I have a problem with this pulling the ships back over the horizon, because I don't think you can see past. Hold on, let me put my camera on. I don't think you can see past your eye level, no matter how high you are. And the P900, take any zoom camera and look down at your feet, and look through the eyepiece, and then see how far you have to zoom out before your feet both are the same size. Like, you lose almost all your zoom with the P900 when you do that. And so when you see something way out in the distance, you can bring it back, but it's shrinking. Like, it's the opposite of a zoom. Some of the P900 is the opposite of a zoom. Like, just look down at your feet and zoom out until both feet are the same size, the one in your eyepiece and then your foot that you're looking at. And then look out, and your zoom's almost already gone with the P900. I don't know if I'm making myself clear, but when you zoom back in, it actually shrinks things smaller than they actually are that you're seeing.
Yeah,
Basically, it doesn't start at the same focal point as your eyes, you're saying. That's what you're saying, aren't you?
Yeah.
Yeah, I understand that. My camera does the same thing. If I want to get my camera to look what my eyes see and my focal point, I have to probably zoom it in a little bit as well. But what they're trying to say is on the boats going over the horizon, they're trying to say that the boat is going over the curve of the Earth. When
Right.
in
Yeah,
reality,
I know it's not doing that.
yeah, when in reality, it's convergence. And because we're on that ground level with that ship, obviously it will converge and it will disappear bottom first, which would be the natural law of perspective, because everything goes to a vanishing point. You know what I mean?
Absolutely, Dave. I agree with that, but I don't think most people realize when they zoom back, like they really make everything shrink, and it looks like they're going way out there, but
Yeah,
really it's not.
if you
It's making things smaller and smaller and smaller, and they're
if you zoom in on the moon with the P900 or whatever, then you zoom back to like zoom back into the normal camera length. It looks like that moon is like about 1,000,000 miles away when you zoom back. You know what I mean? Because it's like full screen, and the next minute it's like a pin in the sky when you see it. You know what I mean? And it does give you that effect that moon is like, wow, look how far that moon is away, and like look how far you've brought it back in. But yeah, I know what you mean by it. It's just
I still feel like you can't see past your eye level. Like if you want to see any further, you have to go up to see further. I don't think you can see past it, even with one of their Lucifer telescopes. I think that's why they put them up on the mountains.
Once it's gone past your point of convergence, yeah, due to atmospheric conditions and whatever, you're not going to be able to see it. You know what I mean? There's
Even
going to be a point. Even with a camera, eventually it's going to go to a point where you can't see it. Otherwise, I'd be able to see Mount Everest from here, wouldn't I? You know what I mean?
Right.
It's just a natural law of perspective what you have to take into consideration.
Well, I think people just maybe should reconsider what they're seeing when they see them videos. When people are zooming back in, like on with them P900s, it's not quite reality. It's making things actually smaller and disappearing, because you could probably really look out there and still see everything you're zoomed out from. Like if you really, really looked with your own eyes, I bet you could still see it.
Yeah, but remember, all the ancients, when their proof of the ball was that this was before telescopes or anything, any kind of optical equipment was around. So they were just using their natural eyes to say, you know what, that boat is going over the horizon. So what we're doing, we're looking with our normal eyes, and when that ship's disappeared from our perspective, which it would have done for everybody else previously, then what we're doing is getting the P900 or whatever camera and zooming in from that point there and bringing it back and saying,
it's magnifying, Dave. I don't think we're seeing any further linearly, like in the distance on that y-axis.
Probably not.
Do you mean like? Do you know when you look?
He was like, I can see this. I can see this building. I can see the colours. I can see the windows. But when I look through my camera, it looks so much further away, and he has to zoom in so much.
Almost all the way, right?
Yeah. Well, I'll give you an example. Yeah. When I zoom in on Jupiter, when I look at Jupiter with the naked eye, I can't see the moons with my naked eye. When I zoom in with a camera, I can see the moons with it. So the camera will bring objects closer, and obviously
I think it's just a magnification. I don't think
it is a magnification, but
I don't think you're in any distance.
All the ancients,
like even on the horizon, if you look out on the horizon, I don't care what kind of telescope you get, you're not going to get any distance. You're only getting magnification.
Can I say something there,
conditions
Richard?
as well?
Somebody else can probably look through that and see a little further, but I don't know. That's just something that I've kind of observed.
Can I say something, Richard, please?
Yes.
You know, when you look through a pair of binoculars the wrong way. Do you mean like that, in a sense?
Yes.
Yeah, exactly. I get what you mean. You can't see further than you can see.
Back, it makes things smaller than they actually are, and then it makes like them ships disappeared, but they were there the whole time. And I'm not saying they went over the curb or we're making them. I'm just saying we can't see past that horizon, past that mirroring effect. No matter what kind of optic we put in front of our eyes won't see it unless we go straight up and higher. It's a flat plane. I get that, but I think it's a misnomer when people are saying that you can pull it back, like you can see it, because I don't know, if you don't have a P900, you won't get it, because you zoom out, and when you zoom back in, you're like, wow, that made it look like it's a lot further than it was. I don't know if I'm.
What I did when I was in Skegness and the lifeboat went out, I watched it go out with my naked eye until I couldn't see it. Yeah, and then I got my camera out, and then I brought it back in. That's how I did it, and I brought it back in piece of cake from actually not seeing it with my actual eyes. And this is what I'm referring to. Like a lot of the proofs for the ball Earth or like from like way before the telescope come out. So they were just using their natural vision to say, yes, that boat is disappearing hull first over the curvature of the Earth. Now, how I would look at that observation is to watch it with the naked eye first. When I couldn't see that boat anymore, because that's gone out of my natural view or my natural law of perspective.
You can magnify it.
Yeah, and then if
but I
brought
don't
the
think
camera,
you're seeing any further than your eye level.
well,
is what I'm thinking. I just suggesting for flat earthers to go out and think if they can see past their eye level.
sometimes you can see the Chicago skyline from Lake Michigan.
Right.
Sometimes
But
you
it's
can't.
at your eye level.
It's all,
I don't think you can see further than your eye level.
yeah, there's always
There's-
constantly changing
I don't know. That's just
atmospheric conditions, but obviously there is a point where, you know what I mean, where your vanishing point is. So yeah, like I say, we can't see forever. That's a given fact. And regardless how clear the conditions are, there's always going to be a point where everything converges. You know what I mean? I bet Rich can explain better when you're out at sea and you've got no land around you at all, and it looks like you're in like a little bubble, I would imagine. So,
and especially when we're looking up, we don't know how far we're seeing. Yeah, but I don't think you can see past your eye level with no matter what, especially at the horizon. I think you can only magnify it. I don't know if does that make sense?
Yeah, well, keep that logic in mind with this. If you're looking at something like Dave just said, you're looking at Chicago from 60 miles across the lake, and you can clearly see it's not a mirage because we know what that looks like. And the people would say, well, you know, you have refraction, the standard refraction, which is raising everything up. And my thing is, well, how can it raise something that's supposed to be hidden by 1,200 feet of curvature if the light has to be going from your eye to the distant object with no interruption before anything could be lifted? You can't lift what you can't see, and then all of a sudden it becomes visible to you. I don't know if that makes sense, but like what you're saying, you can, according to science, at 3.1 miles out, you see
like if I'm looking
at the horizon.
Skyline line this way, you know, like if it's cloudy, it's like right here, like where my arms meet. But if it's a clear day, it's way out here. But I don't think you can see past your eye level.
Well, that's what I'm saying. Yeah. So when you're looking at Chicago, eye level is really, according to science, 3.1 miles away, because that's where your eye hits the horizon. It raises up to eye level. I think it's 3.1 degrees or 3.1 miles for a person 6 foot tall. So beyond that, how can anything be refracted up if it's not hitting your eye to start with?
Right. I think we're kind of on the same page. Maybe
we are. I'm not
being
probably explaining it correctly, but these people say, "Oh, you can only see." You're seeing Chicago. Of course, with that one, it's such a dramatic problem that they say it's superior mirage, which that's what got me into flat Earth. That picture of Chicago.
That was the thing. Yep. And you probably come on the scene right after that. I remember your background, like it was like purple and pink sunrise or something and flowers. Like, remember when you used to do that backdrop?
Oh, yeah. Long time ago.
Long time ago, buddy.
Yeah.
So I've been in this for a minute. But
yeah. So, and my thing, well, I mean, it didn't matter if I didn't even hear about refraction back then.
But I would suggest to anybody who has a P900, before they go out there and do their zoom, look down at your foot and make look through the lens of one, and then make your other foot look the same size, and then look out, and your zoom's almost gone with that thing. But if you draw it back, you can make things disappear.
Yeah, I was told by the camera lady that when I was talking about the optics with the Lake Pontchartrain problem, she said that when you set the camera to the way our eyes see, you're basically at no zoom. And then as soon as you start zooming, the field of what you see starts doing this, getting smaller and smaller and smaller as you keep zooming. And that causes, on the edges, distortion, or can cause distortion, where you get like clouds that are flat, all of a sudden start doing this. And she had a series of pictures that were down on the table that I could look at. And it was very interesting. It's like what you're saying. Some things actually, as you zoom, make them actually look smaller. It was weird, because if you try to keep the same amount in the picture, I don't know what all the different dials you can do on the camera, but some things did look smaller, but they were a little distorted when they try to keep it in the same. Because she said there's things you can do to make it look like your field of view, but you want to bring it closer. And she said you're just going to get distortion. In fact, she's the one that started talking to me about distortion after she saw Soundly's video. I didn't say distortion. She did. And so, I mean, she could see the left side looked more distorted than the right side. She does this every day, so I'm sure it was very easy for her to pick out. So anyway, that's a little off the subject, but my thing is,
if you have a P900, just set it to what you see. Make it match. Make your viewfinder look like what you're seeing, and go from there.
Yeah, well, let's just say your eye level's 20 miles out over the lake. You know, where everything comes together.
Mm-hmm.
How can refraction then refract what you can't see below that? And
I don't think it does, Rich.
No, it can't do it.
Right? No, I don't think it does that at all.
That's why
the refraction mirrors the actual image downwards.
I'm not making myself clear, but yeah, I know there's nothing going over a hump or a curve, because it would have to.
I agree with you.
Okay, it has to leave your feet immediately.
And also, you can, if you look at an object from a distance, what happened is the light actually mirrors the image downwards. Yeah, you can see like the object, and then you can see like the cutoff, and then you can actually see the actual mirroring, which is actually the light's actually bending it downwards. So you can see the refraction is actually bending the light downwards. And they're saying us, no, it's actually raising up. But you can clearly see if you've got like an object, and you can see the actual mirror part, which looks like it's bending the light down, because obviously then you've got like a double part of the actual object you're looking at. You can clearly see that light is bending that object downwards, and it's not bringing it up over a curve, because over a short distance on like a tennis court or whatever, yeah, you know it's going to be straight, and when you're getting that kind of effect from that distance, you're getting over a bigger object like a skyline from a longer distance. It doesn't take a rocket science to put two and two together to realize that it's actually mirroring the object downwards, yeah, and not bringing the object upwards.
Absolutely, because generally speaking, you're always going to be looking through denser and denser layers of atmosphere as you go out. It's just the way it is. You're looking through more atmosphere, it's going to be more dense, and it's going to bend the light the same way.
Yeah, and Phuket did a great video on it recently. So if you just click on his channel and look at his video, where he does a brilliant demonstration of it, really, really concise explanation of it, and it's really, really good. So I would recommend watching that, because he does show you what's actually happening there, and it's a nice little video to watch too.
Can I just say something? There's a question in the chat room, just with leads. They wanted to know, could you ask if they turned one of those massive telescopes horizontal, could they see Everest, for example?
Nope, because you've got the atmospheric conditions.
Science itself says that there's a 29.75 mile vanishing point, or point where we humans can't see beyond. It's obviously not true, because we can see much further than that, but that's what science says, because of atmospheric pollution, humidity, dust,
pollution, particles in the air, anything.
Yes, science itself. In fact, Kent Hovind had this expert on who ended up he was a geocentrist. But Kent Hovind, he was all proud. He goes, "Will you explain to the people why in New York City you can't just look west and see San Francisco?" And the guy turned to Kent Hovind and said, "Actually, they have a point. You can't see beyond 29 point whatever miles." Well, I know you can see beyond that. I used to call 30-mile visibility, 35-mile visibility on extreme rare cases out at sea. And I could verify that. I could go back down, look at my radar screen, say, "Oh yeah, I was right. I can see the destroyer." The visibility is defined as being able to see an object clearly against its background. So that means if I could see the object and it's sharp against its background, and I call that 35 miles visibility, that means I can obviously see farther than 40 miles. And let's say I'm calling 20 miles visibility, but I see a destroyer and I'm like, "Oh, it's starting to get fuzzy there." That's probably 25 miles. You get real good at guessing these things. You really do. And I come back and I look at my radar screen down there, and there's the blip at 25 miles. I'm like, yeah, I'm right. Even though I can see the destroyer at 25 miles, I call 20-mile visibility because I can't see it clearly against its background. It's starting to get fuzzy. And I think today, officially at the Weather Service, you can't call anything beyond 30 miles visibility. But we all know, we've all well, at least here in the United States, you've driven somewhere in the Great Plains and you start coming up on the Rocky Mountains and they're way in the distance and you can see them. They're way beyond 30 miles. You drive for hours before you get there.
Yeah, I saw the Lake District from Southport, and them was like them mountains were at least 70 miles away from my point. So yeah.
Hey, Dave Rich, what about that little video I did? Flat Earth Darb, he was in the chat room earlier on. I went to Silbury Hill, and then when we were standing at the fence, we could see there was a field, then the pyramid. It was still quite big. But when we walked back to the car, there was a few hundred well, I don't know, it was a distance. The pyramid suddenly grew in size through this lensing. It was enormous. You wouldn't even have known there was a field in between the fence and it. It was so big. How does that happen then? Is this what's happening? Is this why you can see further or things?
Well, on the ground level, you've got dense atmosphere, yeah, and you've got water particles in the atmosphere. And what it does, because you're looking through more layers of atmosphere, yeah, it will actually make objects look bigger. You know what I mean? So you will get what you call atmospheric lensing.
Well, that I got to see when I come over, Karen, because that was weird.
Yeah, I can show you that.
Hey, Dave, are you by any chance renting a car in Denver?
No, I'm not. No.
I don't know if you're up for this or not, but if we can find somebody that has a car, my brother, he's been to Colorado several times. I think I drove for it once at night. So, but the Colorado Rockies, especially this time of year, there's going to be snow covered. They're absolutely beautiful. But he said in Denver, you can't really see them. He said you have to drive about 45 minutes west. So I'm willing to go do that if I can find somebody that's got a car.
I'm sure there'll be plenty of people with cars there. Last year there was like loads. You know, Robert Forsh, he's got a car.
Really? Okay.
Yeah. So
Robert Forsh is going. He'll do it, Rich.
His car's covered in truth stickers, isn't it? That's cool.
Yeah.
That would be awesome.
We're going on the journey with him. He's driving from North Carolina. So,
really?
I mean, I can ask him next week.
It's a shame because it's just been banned off Facebook as well, hasn't it, for spreading truth? It's crazy.
Has he?
Yes.
What? You mean he's in jail?
I don't know if he's in Facebook jail. I don't know if he can
Yeah,
post
happened today, weren't it?
Yeah.
He's posted.
Oh.
Right, I'm going to be back in 5 minutes. I'm going to make myself a quick drink, so I'll be back 5 minutes.
Alrighty, Dave.
Okay.
But yeah, what is it you want me to ask him?
Ask who?
Robert.
Oh, well, if he's got a car and he's willing to drive 45 minutes, or I don't mind driving, whatever. I just want to go see it. It's supposed to be one of the most beautiful things you can see in this country is the Rocky Mountains when they're snow covered. And I've never seen it.
I will ask him, Rich.
That'd be cool. He's probably going to start out tomorrow. No, not that quick, but that's a long drive from North Carolina. That's probably 3 or 4 days.
He's leaving next Thursday, but it might take him a day or so to get there. I don't know why he's going so early, but he's going before.
Well, that's about right. He's from Florida or Georgia, Florida, right?
He's Myrtle Beach.
That's 4 days.
He's on the east coast.
Oh yeah, he's I said Myrtle
What,
Beach. That's 4 days. That's 4 days travel unless you really want to push it. You can do it in 3, but that's 4. It's still pushing it some at 4.
I think you can pretty much say safely that the 45-minute drive, he'll easily pick you up there then, Rich.
Oh, he'll be dead by the time he gets there. I'll drive.
I'll ask him.
I appreciate that. It's cool.
I'm sure he will.
Be good company too, especially if Dave could come along. I mean, if you're going to come across the Atlantic, you might as well see one of the most beautiful sights here, supposedly.
Someone's just wrote in the chat room here, dabbing good, that they'll be there at the airport on the 14th or 15th, and they're willing to pick someone up if they want a chauffeur.
Oh, that's cool. That's nice. I'm trying to, let me see. I think I get in the 13th. I don't know what time, though. I'd have to go look it up. I think we're all supposed to have a hangout on the 14th. Uh-oh.
Careful then, Rich.
What's that?
How many days are you going for then? The whole thing?
I'll be there Tuesday and I leave Saturday.
There's an email in the chat there, Rich. So if you take notice there and dab in good, then you can maybe contact.
But I'll put it in the chat room for him on here.
Oh, thank you.
When the chat room stops bouncing up and down. Right, that's it. When more people write, then it bounces. So I'm just going to put it in the chat room for you, Rich.
Thanks, Karen. Appreciate it.
There you go.
I'm trying to remember what time I even get in.
Thank you, Dabin. And how long? Oh, Dave's not there, is he now? Dave, are you back?
He's making a brew.
I know.
Hey, I was going to say, Rich. Horry Sheet Show. He's moved out to Arizona now, hasn't he?
Who?
Horry Sheet.
Oh, really? No way.
Yeah, I'm pretty sure he's moved out there. Yeah.
Well, it's a big state. I mean, it's.
You sure he hasn't moved to California?
Karen, your geography. You need to get back to school, I think. No, he didn't. He's out in the desert.
Oh, right. I can't remember where he says he's gone now, but yeah, he's moved over that way. He's on an 8-hour time difference. Well, you know, he's the same time difference as you, Rich.
Say okay. You mean so he's well, we'll know for sure if he's got the same time after Sunday.
Yeah, he's going to the convention as well.
Wouldn't it be funny? He's just living like, the next street behind you or something. Sod's law, 6 degrees of separation.
Yeah. Anyway, there's loads of good people going. Paul on the Plane's going. Robert Forsh is going. Alex Music Conspiracy's going, and he's singing. Obviously, Dave Marsh is going from this way over this way. It's brilliant.
You're going, right, Richard? Or did you mention him?
Not him. No, I don't know if he's going on. He hasn't mentioned it. No.
Oh, me? No.
What part of the country are you in? I can't remember.
I'm in north central Ohio. Mansfield, Ohio.
Yeah, you'd be another 3 or 4 days away, wouldn't you?
Yeah. It might as well be $1 million. So, no, I'm not going, buddy.
Okay.
And can I make one more point about what if a telescope is no different than a microscope? It only magnifies. What if we're not seeing any further in length? I don't know. That's just a thought I have. And that seems to be what I observe. But no, I'd love to go to the conference. I'd love to come here and high five every one of you. But,
yeah, that'd be cool. We'll get together one day somewhere.
Right. Chew game pool or something. Heck yeah.
Hey, I'm into that. I'll take you up on that, Richard. No problem, brother. No problem.
Yeah, you've mentioned that before, Astral. Like, I believe that's the truth. Like, we're all still around together.
Yeah, we'll do that one day. Surely. One fine day. We'll be there.
Does that make a bit of sense then, Rich? Is what he's saying then? Because I saw I saw you thinking then.
Yeah, I'm not. I got to think that through. I don't know if we can. I don't
think we see any further. I don't think we can see past our vanishing point, no matter what kind of optics we put in front of us. I think we just magnify it. I don't think we're seeing any further.
How can you tell what our vanishing point is without magnifying it, though?
Just what you can see. I don't know, Rich. Like, it's just.
Yeah, you might be 100% correct. I'm just trying to think it through on the fly.
It's just something I've had in my head, and I've tried to mention it to other channels, and they're like, "You're so stupid," and I'm like,
This is something that's hard to explain without talking it through.
Oh, I know. Yes, and I don't have the brain power that you have. This is just an observation that, like, I know what I see. I don't think you can see past your horizon, no matter what kind of lens you put up there.
Well, if you don't have the brain power I have, you're hurting. Maybe what we can do is.
Thank you.
Maybe we can do is think about this. Maybe we can take, maybe I could do something as simple as when I go to the park, because it's actually at a 4 or 5 acre place. That's why my dog loves it so much. But we can do one of those things where you take a small object and you keep lowering the camera until it's cut off, where you can't see it anymore. Something close enough to where you can lower your own self down to the ground and get it to disappear. As we know it does. We've seen the people with the their legs and everything being cut off as they walk away on a flat surface. Maybe we can take an object, get it to disappear visually, and then take a camera, zoom in, and see if it comes back. And if it doesn't,
Right,
then
or not up and down. Let's see if we can take a penny out as far as we can see it, and do our thing with our P900. Get our feet to look the same, and then maybe we can make that penny disappear, even though we can still see it. Is what I'm going to suggest.
make the penny disappear through the camera?
Right, through the camera zooming back out, like, or in, like how it diminishes. I think you could take that out there,
I gotcha.
penny
Okay.
out as far as you can see it, and then put your P900 on it and make it disappear. Well,
Isn't
I'm
that
just saying it might not be a thing that we should really be saying, like. As
Well, I
being
know one thing.
truthers.
I wish I really knew how cameras worked. and
Right?
these
Yeah,
stuff.
I don't. I only know my observations. That's it.
Yeah, I've just got something here from Static Astronomy, and what he did for an experiment, he cut out 3 boards, 3 circle boards, all the same size, and he cut a center hole all the same size. And what he did, he viewed the center hole from a distance, and he worked out when that center hole actually disappeared at the first point. You know what I mean? That's how he worked out your actual your vanishing point, you know what I mean, on certain objects. Depending on the size of the object, if you took a penny, that vanishing point is going to be a lot closer than.
Well, your vanishing points depends on the day.
With
far you can see that day.
with a dime, I guarantee you, it wouldn't be anything to do with atmospheric conditions. With a dime, yeah, it will vanish before, yeah, it's gone beyond your vanishing point due to the natural law of perspective. And it just says there, like it says, if A represents a disc of wood or cardboard, say 1 foot in diameter and painted black, except 1 inch diameter in the center, on taking the disc to about 100 feet away from an observer, the white center will appear considerably diminished, as shown in the image, and on removing it still further, the central white will become.
Maybe I should make my first video.
Yeah, but like I say, with a dime,
make a penny disappear.
Guarantee you, a penny will disappear a lot closer than a bigger object. It's just the natural law of perspective, and that the way you cut a board out, and you cut I don't know, you cut.
Well, you can do it with a car. Take
Yeah,
a car
or
out
you
as
like
far
say-
as you can see it, and then zoom back in that camera with that P900. You're gonna make it disappear. You can take a building, get as small as you can see it, and zoom out with that P900. You're gonna make it disappear, but it's gonna be on a straight line.
I think, Richard, what you should do is make a little video. Yeah, you could do a little video, a minute long even, so that we can exactly see what you're doing. But I understand what you're saying. I think I really do understand what you're saying. But that, if you take like binoculars upside down, that view that you get, you can see your feet. But if you was to turn them the other way around, I'm not going to see my feet out of focus.
Right.
Yeah, and that penny
it's
will disappear.
limited.
That penny will disappear a lot closer when you turn binoculars the other way around as well. You know what I mean? So there's a good example.
Relative, but all right, yeah, all right.
I can see where you're coming from, but like I say, you have to take into consideration the natural law of perspective and the size of the object that you're observing as well. You know what I mean? Smaller objects.
I'm only suggesting that we
will
can't
vanish
see past our horizon.
Yeah,
Even with optics, we have to go up to get our horizon to expand. That's like when we go down and things disappear that are on floor level. The only way we can expand our horizons is if we're taller and we can see further. But
yes, and that
I don't
and
think
even
a camera's doing it. I don't think a camera's seeing any further.
if you look at the SL10 amateur rocket, which is on the GoPro awards, which won the actual GoPro award, I think for 2016. That rocket went to 386,000 feet. Yeah, that's like 70 odd miles up. And what you'll notice is, although it is a GoPro lens, when the field of view is equidistant, you get a perfectly straight line, even at 70 miles up. You know what I mean? And that horizon line is still at eye level. Now, if that's not proof of a flat surface or a flat plane, yeah, at 70 miles up, then I don't know what is, because I'm sure if we lived on a globe at 70 miles up, we would see some kind of curvature. So,
Mr. Marsh, I believe I live on a flat plane.
Yeah,
like,
I know you do.
Okay. All right. Yeah, I don't know.
I'm just giving an example of like how the horizon always rises at eye level, and like I say, yeah, as you do rise up, obviously you can see further, and like I say, high altitude balloon footage proves that.
I think if you zoom in at one story or 10 stories or 5 stories, you're not going to zoom any further out that way.
Yeah, what they don't take into consideration, a lot of globers don't take into consideration when they're looking at this high altitude balloon footage is, remember that a GoPro
it's
shoots
something we can all go out and observe.
Yeah.
Maybe nobody really thought of it.
A
I don't think
GoPro shoots 180 degrees. Yeah,
What
so you're seeing a hell of a
Really
lot of
magnifying.
horizon line. So when you go up to the stratosphere with a high altitude balloon with a 180 degrees camera on it, you're still seeing the piggy cam shooting a complete flat horizon. Yeah, and remember that's 180 degrees of field of view you're actually getting from a GoPro. It's not just a small section like when they put a camera close to a basketball. You know what I mean? You're seeing quite a lot of horizon line from a 180 degrees camera. So it is, you know what I mean? For me, it's a good proof that the higher you go, you can see further. Yes, or within reason, but the horizon line always rises to the eye level, even like I say, at 396,000 feet. Even though you've got a GoPro lens, but when you get that, you get a true representation of a GoPro lens when the image or what you're observing is equidistant and it sits in the middle of the actual camera. Obviously, when the camera dips, yeah, you get a convex image, and when the camera rises, you get a convex image. But you get a true
convex, concave, depending on the horizon of the GoPro.
Exactly.
Yeah,
you get the true.
flat.
You get the true flat horizon when it's equidistant.
Yeah, I agree with you, Dave.
And that's what ball earthers use as proof of the globe. You know what I mean? And I'm sure you've seen the new Neil deGrasse Tyson video when he goes, "You can't see the curvature of the Earth when you're 2 millimeters above the bleach ball." So if you haven't seen it, look it.
Can I just say that Rich has got about another half an hour here. So, Rich, is there any other things you want to talk about today?
I will let the grown-ups talk.
Oh yeah, sorry.
I appreciate. That's been on my mind, and I've tried to mention to people. And somewhere out there's not a deaf ear. Somebody will hear that.
You said that, though. I could see Rich, the other Rich, was thinking about it. So, yeah, it's not a stupid thing. We're all here to learn, aren't we?
There is no question that, or no, you cannot ask a stupid question, Rich.
Right. Well, it's an observation that I've noticed.
Exactly.
So
yeah.
it's
That's
not even a question. I'm just
No,
trying to.
Do a video.
It's what we love, isn't it? You know, we think about things,
Yeah,
and
that's why I would
people
recommend.
That's why we're family united.
That's
Yes,
right.
Yeah.
I'd recommend making a simple video. Like I say, if
Somebody else can. That's not what I do.
if like I say, I mean, I never made a video till I started looking into flat Earth. You know what I mean? I'd done anything like this before this. You know
I might never make a video, but I'll come on this panel when I'm invited. If I didn't wear up my welcome tonight, but
Yeah, we're glad to have you here.
Yeah, like I say, we're all in new
just a
territory.
thinker, man. Like I think outside the box. Like
That's why you're here.
Exactly.
If you did, you believe in a spinning ball, even though your senses and everything tells you elsewise.
Oh, I remember coming home from school and asking my dad, "Do we live on a ball?" And he's like, "Yep." And I'm like, I didn't answer it. I didn't question that again until like 3 years ago. Like,
None of us did.
no, I know. It sucks. Man, imagine what we'd know if we knew. the truth. Like if we were born into truth.
Yeah, imagine what it's going to be like 10 years from now.
It's got to be better, I hope.
Well, if you look at the statistics, if you look at the analytics on Google and things like that, it's just growing constantly on a daily basis. You know what I mean? They're doing all the best they can to add them algorithms and stop flat Earth. Certain videos appear at the top of their search engines, because when you Google flat Earth, you get some like weird news footage. Like I think you get the conference like from the news article side of it. Then you get the Flat Earth Society, which you know has got members all over the globe, and like I say, it's you don't get all the good stuff, all the cream of the crop when you Google. You know what I mean? If you don't know certain channels or certain individuals, then you when you look on Flat Earth and you see like some article ridiculing it, or you click on the Flat Earth Society, then it looks like to me like it's there for a reason. You know what I mean? When you do hear about Flat Earth, oh, what's this? Google Flat Earth. First thing you get is Flat Earth Society and some news articles ridiculing.
That's what I
together.
Get a lot of disinformation and debunking.
Is it reflecting your own?
That's
When
why
I looked it up, I could see all the debunking ones and all the ones taking the mickey, and then I looked down there and I saw Sun and Moon there on the first page.
Well, that's good. Hey, can I just interrupt you? After this conference, though, it's going to be much easier for people to find real flat Earth content, you know, because they'll be seeing who's there up there talking. They'll be seeing Dave Marsh. They'll be seeing Mr. Thrive and Survive, you know. They'll be seeing Robbie Davidson and Rob Skiba and Patricia Steer, Mark Sargent, whoever else is going, all these people, knowing full well that these people have got foundation behind them and they've done the research, you know. We've been looking into this for some time now, so they'll know who these people are and the ones that we can look at and the ones that, you know, well, they're just trying to debunk the flat Earth or whatever.
There's lots of literature, lots of articles about the convention here, and yet loads of people didn't see it. Yet there were articles, so I just hope they don't do the same for this one. But can I just say that Rich hasn't got that long to go before he has to leave, so I just still wondered, he's muted now. He's got his camera off. He's obviously popped off for a second. Rich. Rich. He'll be back in a second. Yeah, I hope they don't do that for this convention then as well, that they don't do the same thing.
Well, they did last year, didn't they? You know what I mean?
Yeah.
I watched a really, really funny video. I can't remember what it was called. Robert Forsh is in the video as well. It's basically just a piss take of flat Earth, really. But the way the video's been put together, it's so comical. You know what I mean? It's really.
Is it the PewDiePie one, maybe?
It could be.
That Swedish guy. He's had something like 15 million hits. Sorry,
it might even be that one, actually. I'm just having a look on my history now on my actual phone. And
is it where he's talking about toilet water?
Yes, that's the one.
It's so funny. Yeah, it is funny.
It is really comical. I loved it. I did.
Weren't he taking a mickey out of, or wasn't he taking a mickey out of Patricia Steer as well at some point? But
yes,
it's dead funny. Yeah, it's dead funny that.
It is a funny video. If I'll try and find it and I'll send it to you, Karen, because it just watch it. It is like really comical.
I've seen it. Robert's played that part for us.
Oh, has he? Oh, yeah. Well,
to show that, you know, he thinks it's funny.
Yeah, I mean, I think it's comical. I like it. Like I say, I watched it and I sat here and I pissed myself laughing, like, because I just thought it was brilliant. I put it together. You know what I mean? It just.
One thing they haven't noticed, though, anybody, all these globers, it's not just one section of people that are into flat Earth. It doesn't matter. It captures every community, like color.
We come from all walks of life, basically, don't we? You know what I mean?
People, it doesn't matter. It covers everybody.
Yeah, like I say, it's like a good example of that is when somebody put the article out. I don't know what news outlet it were, but they put the article out that flat earthers say Australia doesn't exist and it's run by NASA spies. You know what I mean? Apparently, that was one person who had that belief. You know what I mean? That Australia didn't exist, but they made out that it was flat earthers in general, who believe that Australia doesn't exist, which is absolute nonsense when there's plenty of flat earthers in Australia. You know what I mean? So it's how they put the little spin on it. You know what I mean? That's what makes me laugh. And after the convention, watching the news articles, it was like Chinese whispers as it went on. As every new article came out, they just changed a little bit and added a little bit more. You know what I mean? By the time they get to the end of it, a few weeks down the line, the article has gone from a small convention in Birmingham to Australia doesn't exist. You know what I mean? That's how the evolution of the media turned that article, which was quite interesting to watch it unfold.
Yeah, well, they was like, there's different spins, don't they? If they don't want it to look that good. But Rich is back now. He says that he's got to go at a certain time. Is there anything else you want to talk about, Rich?
No, the only thing I wanted to say before we totally left the subject of ships going over the horizon, they appear to go over the horizon starting, I don't know, 3, 4, 5 miles out. And by 10 miles, unless you're talking about a huge ship, I'm talking about a regular sailboat, something like that, it's totally gone. And I'm being a little generous with 10 miles. But yet you can go up in 40,000 feet in an aircraft. We've had also balloons go to 135,000 feet, total flat, no curve seen, but yet ships disappear, boats disappear over the horizon in 5 to 10 miles. So something doesn't jive there.
Yeah, both contradictive each other.
Yeah, so which one, I mean, when you understand natural perspective, like Dave's been talking about, it's hitting the vanishing point. That's all it is. And that mirroring down, that refraction down.
Hello?
I think we might have lost Rich.
Oh, I thought it was me. I was thinking, oh, my internet's gone.
Yeah, I thought it was me. I thought I was messing about my phone.
Rich, come back.
Yeah, I thought it was me because he's been doing that with me all the time, so it was just normal for me. But I think he'll be back in.
I really thought it was me because that's what happens. It just doesn't even warn you; it just donks off, and everybody. I'm still here, but I can't hear anybody else. Anyway,
Rich is probably still talking now to himself, because I've done that a few times. Like I've had a carried on with the conversation for about 10 minutes and realised I'm not even online.
Yeah, that's what happened to me. I thought it was me. I wasn't sure what to do. Then I was thinking, do I go on my phone? What's going on? I'll just message him. Rich, I just messaged him. Rich.
Well, since there's a downtime, can I mention another observation?
Go for it.
Yeah. Have you guys seen Rob Skiba's video where he shows that at 6 feet, like the guy gets smaller and smaller and smaller?
Yeah.
Yeah. But wouldn't that be like at 3 miles, he's not shrinking this way. He's falling away from you this way. And we all know we can see
it should be, yeah,
people 3 miles and they're not leaning over. You can still see their feet. Like, they don't disappear this way. They would have to be leaning away from you.
Well, that's what we've said, haven't we? Because when they say, "Oh yeah, what you're seeing here is a mirage," but what you're not seeing is buildings starting to slant. Yeah.
But even at 3 miles, a 6 foot guy should be at least 45, I would suggest, from you.
No, it's actually pretty small. Can anybody hear me?
Well, yeah, actually, Richard, actually working that out, because you're supposed to stand 90 degrees to the, perpendicular. If you stood upright, you're 90 degrees to what you stood on, aren't you? Yeah?
Yeah.
So we could work it out then. However many miles away they are, according to the curvature, work out then what that should be and how much you should be leaning. And if you're 6 foot, it will not seem more than 3 foot at that height or whatever it is,
It's actually been worked out and it's minuscule. Really is.
Right, but he's not going down. He should be leaning away.
Well, he should be leaning away the same as he's going down, really.
Right.
But when you actually do the calculation, it's a long way away before you'd even notice even 3 or 4 degrees tilt on a building, let's say.
Yeah, and not only that, the person would disappear long before the...
disappear if he didn't lean away from you. The ball doesn't make any
Well,
sense to me.
well, if you want to work it out, you have to take the observer's height, and then you set the distance, obviously, and it's 8 miles square the distance. So it wouldn't take much working out to see how long you need to be away from to disappear.
Okay, yeah,
I think I know what
thinking out
you're
loud.
saying that. In all the pictures, if you're zooming in, the people on a globe should be leaning, and they're not.
Well, like Richard just said, it'd be very, very minuscule what you'd see. You know what I mean? And not only that, you don't only see it. You'd probably see it on the horizon line as well. You know what I mean? If you were going to see any curve, but unless they're on a toilet roll. So, yeah. All I would say is, like I say, on a person who's 6 foot tall, that person will converge. His feet will disappear first, due to the natural law of perspective. And I think Rob often mentioned that on the experiment where he filmed somebody, shot him with a telescope from a distance on ice, and all they could see was their actual shins on the ice. You know what I mean? And not the actual ice skates.
Hey Dave, on your camera, can you see the red spot on Jupiter?
No, I've never seen it with my camera.
Have you ever wondered why? I mean, we've seen drawings from way back, since the telescope was invented, of this red monster storm supposedly on Jupiter, but how is it always facing the Earth? Because it never changes. It's always facing the Earth.
That must also be locked in orbit with Earth as well, then.
No, it's supposed to be its own orbit. I can't remember what it is like, but all the planets have a different orbit speeds and what have you. So,
What are we tidally locked to Jupiter?
Yeah,
That's what I'm saying.
Interestingly, what I did notice, this is only a very, very little thing, but when I was reading Ptolemy's Almagest, when he's referring to planets, he's talking about apogee and perigee on planets. Now, you only refer to apogee and perigee when you're referring to moons. Yeah, it's aphelium and perihelium when you're referring to planets. But in the book, Ptolemy, he refers to all the planets being an apogee or perigee, which I thought was very strange because they're not using the proper terminology in that book. And all the ancient Vedics believe that all the planets were similar to our moon as well. So I'm thinking...
Can I ask you, Dave, sorry, when was it they first started using that term, apogee and perigee?
Well, 2nd century Greece. So, and he's probably got the term from Hipparchus, which was 2nd century BC. So that's 400 years before that. So you know what I mean. You're talking way over 2,000 years ago.
Yeah, okay, so they
apogee,
have been using the word. Yeah.
So apogee and perigee is not just related to Kepler's law. Yeah, like they'll tell you it is. Yeah, it's only related to Kepler's law due to planetary motion. That's wrong because it's documented in Ptolemy's Almagest, and it's referring to planets being at apogee and planets being at perigee, which they should be using the term aphelium and perihelium. You know what I mean, when referring to planets. So it's a strange one. I mean, I'm sure that Toomer, when he translated that book, he knew what he was translating. So it's an interesting subject because, like I say, all the Vedics believe that all the planets were actually like moons. You know what I mean, with Venus having phases and what have you and stuff like that. So it's an interesting point. Like I say, you can't get a lot out of it, but it does just open up a few more little doors to look into. You know what I mean?
Wasn't he a geocentrist?
Yes. Well, the book's obviously based on.
So maybe he thought the planets were our moons.
That's what I'm thinking. Like maybe the ancients did actually look at them as moons, like the Vedics did. Because I definitely know that the Vedics did. But the way the Toomer might have translated it to, like, obviously to the English, and you know what I mean. There could be a lot of stuff. He could have sorry about my language. He could have represented that himself. You know what I mean, by translating it in his own kind of way, if that makes any sense.
Can I just say they translated a lot of this from Sanskrit, didn't they? They've translated a lot of it from Greek. A lot of it was Latin as well, wasn't it?
Well, the original was
Arabic.
Greek, and then it was translated to the Arabic, and then it was translated from the Arabic to the English. So
Arabic to Latin and Greek. That's what I've also found out.
Did it go through the Vatican's hands?
Well, I reckon so, because part of the book, they thank the Vatican for the information. So yes, they hold a lot of that information from that book. So you know what I mean. Once it's gone into their dungeon, then you don't know what's going to happen to it, or
exactly
or what interpretation they're going to give of it.
We
But,
need to
yeah,
see
like
the
I
original.
say, that was an interesting point. That was, yeah. And like I say, it is documented in Ptolemy's Almagest in regards to, see if I can find it here. There,
Yeah.
I've found it, and I'll just read this little bit out for you.
Oh no, we haven't lost him, have we now?
No, I'm still here.
Oh, go.
It just says here, there is further consideration that if we sail towards mountains or elevated places from and to any direction whatever, they are observed to increase gradually in size as if rising up from the sea itself in which they had previously been submerged. This is due to the curvature of the surface of the water.
Which nobody can ever show curvature of water, ever.
Exactly. But I think he's just interpreted that in his own kind of words, because in the original transcript, I know that the ancient Greeks, when they referred to the Earth, they actually referred to it as a discus. They called it discus. And now to me, that would probably translate better to a disc than it would actually to a globe in my eyes. Like,
yeah.
So it's interesting, because the more I read that book, the more I think of it. It's been obviously interpreted how they want it to be interpreted. You know what I mean? You know that they mix these truths with lies. I think that book is a good example. Yeah, where Ptolemy probably thought we lived on a stationary Earth with a celestial sphere around us, but probably never really mentioned much about the actual Earth itself, because a lot of observations were obviously the sky itself. So to me, it looks a bit sus. And like I say, where he's referring to the planets, and there's only 5 of them in Ptolemy's Almagest, come to think of it, he's referring to the furthest point and the closest point to be apogee and perigee, which is terminology only used for moons. So that's something interesting.
I think it's interesting that both the geocentric and the heliocentric model, they can make work mathematically and everything.
Well, yeah, because Ptolemy's model were used for 1600 years prior to Copernicus's model, weren't it? You know what I mean? That was the model to refer to, which predicted all eclipses and all natural phenomena, everything. So,
can I interrupt you? You know, before you said Ptolemy, he was the one who was. Did you say he was geocentric?
Yeah.
Heliocentric.
Yeah, Ptolemy's Almagest is based on
the
geocentric model.
Yeah, okay.
What his model was based on what you call epicycles. Yeah, so it's like circles within circles, if you know what I mean. So everything orbited round on a circle within a circle. I don't know if you've seen that flat Earth model where you got the A model, and to show how eclipse work, you've got like a sun and a moon circling around it like the actual circle. Then they match up, and then that's how you get the eclipse. Well, that's what that's doing. That's using an azimuth equidistance map and putting Ptolemy's epicycles on top of it, which is absolute nonsense.
Absolutely, I agree with you 100% there. One on top of the other.
Yeah, exactly.
Anyway, yeah.
Right.
Is there anything else you want to say then? Obviously, we're very excited to see both of you two together in the convention in a week and a half. That's going to be great.
Yeah, I'm really looking forward to it. You know, I've just like the last 6 months, I've just put my focus on getting myself ready for the conference. You know what I mean? I've just given myself a goal, like a focus, and that's what I've done. And I'm getting so close now. You know what I mean? It's getting exciting. I'm really looking forward to it because I think.
One of you to send me a picture of you two together. I want to see a picture.
Well, I've met Rich last year, so yeah, I had a little chat with him last year.
Together.
Like I say, there's going to be a lot of people there, and I think I know Robbie Davison has just posted that all the VIP tickets have been sold out, so it's looking like there's going to be quite a lot of people around.
Yeah.
Yeah, we'll try to get a group photo because there's supposed to be a hangout Wednesday night.
Oh, is it?
That's what I understand. Yeah.
Oh, that'd be cool.
There's supposed to be a meet-up at the big billboard beforehand as well. I'm not sure about the Thursday.
That's on the Wednesday, yeah. Wednesday daytime, so I'm led to believe.
Very exciting stuff. Anyway, I suppose we need to finish now because Rich has to go. He already said before he came on how much time he had to give us. But can I just say thank you, Astral. Thank you, Richard. Let's be PractiCOOL. Thank you, Patricia. I know she's been very quiet. Thank you, Dave Marsh. And of course, thank you, Rich, Mr. Thrive and Survive.
Thank all of you.
Yeah, thank you all. It's been a pleasure. I've really enjoyed it.
Yeah, thank you all as well.
Look very forward to meeting you again, Dave.
Yes,
cool.
Yes. Look forward to meeting you in like I say, a week and a half. I'd say. Yes, I'll be getting there Tuesday afternoon.
Anybody in the chat there? Look us up.
Can we say goodbye off air? We'll say goodbye off air, but on air. Thank you to everybody in the chat room. Mwah! And we're back on Monday. But thank you again, Rich, Mr. Thrive and Survive, Dave, Patricia, Let's Be PractiCOOL, Rich, and Astral. Bye, everybody.
Take care.
Bye-bye.
Bye-bye.